Hey, Rachel, we are just giving things a few more minutes as people hopefully trickle in here, and then we'll get started in a few minutes.
Hey, thanks, Al.
All right, Rachel, I think we'll get started here. So I'll be kicking off, and I'll let you know when it's your turn. That being said, to the folks live here this morning, good morning. I'm Al Reich with Barr Engineering. I'm a chemical engineer with almost 10 years of experience doing primarily air quality permitting and compliance work at liquid terminals, pipeline terminals, refineries, anywhere where there's a tank. I've typically had some involvement with a permitting action or compliance challenges or compliance solutions in some cases. And that's, so I'm from our Duluth, Minnesota office, as well as my colleague on the phone, Rachel Shetka, and Tony Schoberg as well. Here, let me get to our, ooh. There we go. Rachel, if you could give a quick introduction of yourself.
Thanks, Al. Good morning, everyone. I'm Rachel Shetka. I'm also in Barr's Duluth office. I've been with Barr Engineering for almost 5 years now. My work focuses on environmental review and permitting for a variety of project types, including liquid fuels, terminals, and pipeline support. Prior to working at Barr, I was at Enbridge and supported environmental department from maintenance projects all the way up to major construction on capital projects for almost 12 years.
All right, and then also Tony Schoberg will be joining us as well remotely, also from our Duluth office, and much like myself, he has about 15 years of experience doing all manner of air permitting and compliance support with terminals, tank farms, refineries, and a variety of petrochemical sources. So kind of that's a little bit about us. Talking about the course now, our goals are to gain a basic understanding of the types of facilities and operations, the sources of pollution, whether it be air, water, or waste, that come from liquids terminals, how to understand and comply with permits, with programs. We're not going to deeply dive into the specifics to a citation level, but we'll cover sort of a broad awareness to make sure that you've got a good knowledge base and understanding of the applicable regulatory and environmental impacts of operating a liquids fuels terminal. What's not covered, like I said, we're not going to go into super detailed discussion. However, we have a small class today, so as questions come up, I would much rather have an enjoyable conversation than sit here and lecture. We're not going to go into the outside the fence line pipeline operation. We will talk about pump stations and other ancillary facilities from an environmental perspective, but in terms of maximum operating pressures and DRA skids and fun operating requirements, we're not going to get into that. And in this presentation, we're not going to talk about gas stations, and then we're not also PHMSA regulatory folks on this call, so we'll be letting that one go without too much comment. So already introduced Rachel and myself and Tony. Just a bit about Barr. We're an environmental and engineering consulting firm. We have 10 offices across the US and Canada. And we are, we both serve clients supporting environmental permitting, compliance, and other remediation, water quality issues, as well as providing engineering and design services for a lot of our clients as well. Most of us presenting today are from the Duluth office. Corey Mead will be stopping in to help support a few slides as well. He's from our Salt Lake City office. And we also have folks from our Minneapolis office here that will be providing some presentation support as well when their sections come up. I did jump the gun a little bit on the presentation introductions here. So you know about us and our slightly changed roster here. However, we have a small enough class that would be great to get an introduction, just a little bit of information from you guys around your background responsibilities, just so we can make sure that as we go through this, I can provide more tailored or relevant context. So a couple questions here, if we want to start over here.
Gas provider.
Hmm. Okay, so like inventory management, tank levels, emission calculation stuff, or, okay, awesome. Awesome.
My name is Keith. Keith.
Okay, awesome. Good deal. All right. Thanks, everybody. So just kind of to break it down a little bit more, what we'll end up talking about this morning in terms of our terminals and environmental impacts, we'll start by breaking down general facilities along the liquids fuels terminals industry segment, intermix our air quality emission unit discussion through that. As we talk about the facilities, it's pretty easy to then bring up the emission units and address those. Talk about applicable regulatory unit or applicable regulations. We have kind of a general topics on good to know environmental air quality issues that we'll reference. On the water side, then the types of facilities and air quality discussion will take up about the first third of the somewhere in there about the first presentation. Then we'll switch to water quality. We'll talk about water pollution sources, applicable regulatory programs, same format, typical and unique compliance issues. We'll have some discussion on oil pollution prevention programs and what those look like from a terminal's perspective, talk about waste management. Then we kind of, towards the end, get into questions and topics around facility expansion, what to do for projects, key considerations from a terminal's perspective, touch on EPCRA programs that apply, cover some additional environmental challenges and other hot topics, and then kind of speak to environmental management systems and ways to tie together your compliance demonstrations and how to either, if you are a terminal operator, support a terminal, or if you're a consultant, be able to provide context and insight to better support terminals of all size. That being said, any quick questions off the bat here? All right. So we'll start with the terminal operations and air emission sources. So types of facilities, we're going to cover sort of a broad range from the small to the large across the terminal spectrum. We might be, we have clients, Barr has clients in North Dakota that have just a small, 4, 6, 8, 12 pack of LACT tanks, lease automatic custody transfer units, tanks that get crude oil from tanker trucks, meter it, inject it into a pipeline, tiny facilities, gathering stations, pump stations, pipeline breakout stations, terminals. We'll kind of walk through all of these and provide some context around their emission sources, regulatory programs, and other information. So from a terminal's perspective, right, we have crude oil production, crude transportation, breakout, refining, terminal for bulk distribution, and then ultimately we get to gas stations. From our presentation today, right, we're talking primarily about the crude oil breakout, or I'm sorry, the gathering and breakout from the upstream perspective, and the terminals on the downstream side. Granted, refineries certainly have a significant tanks component as well, and those will be, that will be certainly intermixed and referenced in here as well today. So first we'll start with a crude oil gathering and breakout station as our sort of example facility 1 to talk through emission units and other context around terminals. So this is just a GIS shot of Crude oil terminal, we can see there's a number of different kind of moving parts here. Right now, we can see some large floating roof tanks, which again, when we talk terminals, is going to be kind of our primary emission source, primary unit of interest from an emissions calculation perspective, regulatory perspective, and obviously what's typically the most visible. Down in the lower corner here, we can see, as I referenced earlier, what's called the LACT unit, Lease Automatic Custody Transfer, that these tanks are set up to a LACT skid that has some metering equipment, some testing equipment, and allows for producers to unload or transfer their crude to a larger interstate pipeline and ship it to wherever it's going. A lot of times, these LACT units are ancillary facilities to a larger crude oil terminal. Yes. Lease automatic custody transfer. Yep. And that's typically associated with the upstream, from the well to the pipeline transportation sector. Right. So obviously, right, we'll have storage tanks are sort of our big topic of discussion from the air world. We can have fixed roof storage tanks. So typically, right, fixed roof storage tanks are the most commonly thought of, or from the layperson understood storage tank. They've got a shell and a roof that can be a cone or a dome. Pretty straightforward. Sometimes they're self-supporting. Other times they need to have fixed roof support columns to hold up that roof. More interestingly, right, we know that from a regulatory, environmental, pollution control, odor perspective, we have floating roof tanks that will then not only have a tank shell, but then also a floating roof that rests directly or floats directly on the liquid. We can have an external style floating roof tank that has the roof, or that does not have a fixed roof over the top of the tank. Or we can have an internal floating roof tank, which is a combination of the floating roof features as well as the fixed roof above that. And from an emissions perspective, the fixed roof here helps mitigate wind-driven effects and can lower emissions overall, and we'll get into that in a little bit here. So floating roof tanks, right, from an emissions pathway perspective, for fixed roof tanks, we have working losses and breathing or standing losses. So as, I guess there are two ways to kind of characterize the function of emissions from a storage tank. And the first would be the working losses, and that is anytime material is pumped into a tank, your liquid level for a fixed roof tank is going to raise, and as that liquid level increases, you're displacing a saturated vapor space, creating emissions. Additionally, even if the tank does not experience any throughput, but simply has material in it, the diurnal temperature changes or heated temperature impacts of an insulated tank or a heated tank will also cause cycling in your tank temperature, driving vapor pressure increases in some type of a cyclical fashion, resulting in breathing or standing losses. And that's just a function of the tank being in operation and storing material. For floating roof tanks, the emission pathways are generally pretty similar. Unlike the fixed roof tank where we displace vapors when we put material into the tank, with a floating roof tank, when we put material into the tank, it's raising that liquid level underneath the floating roof and pushing the floating roof up, not specifically generating emissions from that perspective. However, as we take material out of the tank, the liquid level will decrease, and you'll leave a thin film of material on the interior shell, and that evaporation creates the working or withdrawal losses from a floating roof tank. Similar to the fixed roof tanks as well, we have standing storage losses. So that's going to be from our rim seals. So even though our floating roof tanks have rim seals along the perimeter of the floating roofs, those rim seals, of course, are not perfect and are a primary source of emissions from a storage tank here. And that is part of the standing losses. So the standing losses include the rim seal losses. We also have deck fitting. So on the floating roof, there can be a number of appurtenances or penetrations through the roof, such as access hatches, gauge hatches, vacuum breakers, a number of different deck fittings that facilitate tank operation. And each of those individual deck fittings, if it's a penetration through the floating roof into the stored liquid, will result in emissions of some kind or capacity. And then finally, floating roofs construction can be welded, which has no emissions, or if the floating roof is bolted together, you also end up having emissions from a deck, what are called deck seam emissions, so that not perfectly sealed welded deck seam is also an emission source. So if you have a floating roof that isn't welded, you end up with 3 potential standing loss sources you have to be mindful of. So that kind of constitutes the routine losses from floating roof tanks. Then additionally, with a floating roof, we have a different calculation methodology once your floating roof lands. So once that roof, once the liquid level is low enough that the floating roof legs hit the bottom of the tank and your liquid is no longer in contact with the floating roof, there's a different calculation methodology that exists to account for and represent what are called landing losses. So that's you no longer have the control of the floating roof and the rim seals, but rather there's now an exposed vapor space below the floating roof. Your vacuum breakers are open and your tank is going to be venting to the atmosphere much more freely. And then there's kind of the flip side to that is when you fill a tank as well, your vacuum breakers are open, your liquid is not directly in contact with your stored, or your liquid is not directly in contact with your floating roof yet. So as you're filling up that tank and floating the roof, you're also expelling a significant amount of vapor or emissions from that filling activity until your floating roof is indeed floating again. And then our last bullet here, tank cleaning and degassing losses. This actually applies to both fixed and floating roof tanks. But we most typically end up dealing with it with our clients that have large floating roof tanks. And that's, again, as you take a tank out of service for an API 653 inspection or some other maintenance activity or are decommissioning it or what have you, when you clean and degas a tank, there's now a formally published in AP42 emission calculation method for calculating cleaning and degassing losses. For a long time, this calculation approach did not exist in AP42, which is the generally available calculation methodology for floating roof storage tanks. It existed in API documentation and has been around for a number of years, but the lack of inclusion in AP42 has kind of driven slow adoption of accounting for or looking at tank cleaning and degassing emissions across the industry. Some states have more awareness of these and have work to address them on their own, but it kind of varies from state to state. And if you don't have cleaning and degassing calculations accounted for in your potential to emits from an air permitting perspective, or at a minimum are not accounting for them on your actual emission inventory calculations, that's a good first place to start. And we'll talk about these in a little more detail as well, but that's sort of a key overview of the emission pathways from tanks. Then for all of these emission kind of methods or categories, it comes down to a few key variables that impact emissions. And I think the most overall significant one that can change or have variability is the vapor pressure of the stored material. So if we have high volatility crude oil or high RVP gasoline or something like that, the higher the vapor pressure, the larger the emissions. Throughput is another big factor that drives our working losses. As you put more material through the tank, you're going to get more working losses. Temperature is another big one, and this one can be kind of tricky. Well, it's not super tricky. It's ideal gas law chemistry for the most part to get our equations for our emissions. However, as we've seen with clients, we're having more challenges around as they are pushing their pipelines harder and getting more heated material or getting frictional heat gain in the pipelines. They're having higher receipt temperatures at their terminals, and therefore their tank temperatures are increasing. And we have to keep a closer eye on vapor pressures in their storage tanks from a true vapor pressure or TVP compliance perspective. So temperature typically is just a function of ambient temperature and the bulk storage temperature of your tank, and there's allowable calculations that you can essentially correlate your ambient temperature to your bulk liquid temperature if your tank is an ambient temperature tank. However, that saying your tank is an ambient temperature tank without further investigation can be a potential pitfall to be aware of, especially if you're going to be experiencing significantly higher than expected tank temperatures and are storing really volatile material. And then finally, those are all sort of operational, what's in your tank. parameters or variables. And then of course the tank physical properties, what color is your tank, what size is your tank, what's the diameter. Diameter obviously plays a significant role in the emission capabilities of your tank. What type of deck fittings, do you have a primary and a secondary rim seal? All those kind of factor into the overall calculation of our emissions. So I think, oh, yeah. Mm-hmm. Yeah, so that's an excellent question, Brooks. And we'll talk about that a little bit down the road. But just to kind of tee it up a little bit, from the tank's perspective, right? If we're talking about building a new tank, there's a significant design process that goes through, and hopefully by the time you get to the probably not 30%, but 60-90% design issued for construction, there's still some lead time. It depends on, right, are you building one tank or are you going through PSD and having a significant air permitting action that will take many months. But hopefully from the permitting pre-construction angle, you can get a concrete design of what your tank is going to be. So you can have an inventory, you know what your deck fit, or you know what your diameter is, you know the size and color of your tank, you know what your deck fittings are going to be. And then ultimately you'd add that into your existing program of tank inventory, deck fitting management, that, like I said, we'll talk about a little bit. But what we try to help our clients do is develop for their storage tank program, in their compliance manual or compliance program, whatever you want to call it, a deck fitting inventory, which is, you know, an inspection program from the environmental angle that looks at what their deck fittings are, what their tank parameters are, and making sure that that is something that is active and maintained in an evergreen document. So understanding your tank properties is really important. From, like you were talking about, due diligence work, it's good to have, you know, you can't climb on every tank in an acquisition process, but, you know, looking at, are their records relatively current, or do they have one drawing package from 20 years ago, and you know you've had at least 1 or 2 out of service cycles? Have there been expansion projects at the terminal? Could they have added something because they under-designed the tank venting process or something to that effect? So we'll talk about some kind of how to manage that physical properties of your storage tanks to make sure you've got the right stuff. Because right now we're talking solely from how to calculate your emissions. Do you have 5 tons coming from your tank or 5.2 tons coming from your tank? But there's also a significant regulatory burden to that as well, because if your tank is subject to any of the regulations we're talking about, you're going to need to have certain controls, gaskets, sleeves, etc., on those deck fittings. And when your inspector comes knocking, they very well may ask to see your documentation on, okay, this tank 7, is subject to NSPS, New Source Performance Standards, subpart KB, the typical storage tank rule. You're supposed to have XYZ controls. Here's what you say you have. How do we know they're gasketed, or something to that effect? So then if you have good current live documentation and a strong program to show and support that, you can show them your records. They might want to climb the Gagers platform and take a peek down at the tank, or they may be confident in that and then move on. So it's, to circle back to your question, where do you start? It sort of depends, right? If the client or the facility has a strong program to start with, that's a good point to look at in terms of how are their tanks designed, what information do they have, and then kind of go from there. If they have nothing, doing an internal audit, maybe something under attorney-client privilege, to sort of cast that net and get a snapshot of what you're looking at if it hasn't been looked at in a number of years. A lot of times also tanks are built a couple decades ago and they just operate. So there may not be significant change either, but if you don't know what happened in that time period, it can be a bit of a something you definitely want to check out. Yeah. Mm-hmm. Yeah. Good question. So it's again, we'll talk when we're talking air regulations primarily from the NSPS KB perspective. That is a universal general basis. I mean, MAC to WW is kind of the other analog. But from a KB temperature perspective, you're doing, so back it up one more time. NSPS KB does not talk specifically about emission limits for tanks, unlike some other regulatory standards that say thou shalt not exceed 7 pounds per hour of SO2 or something. That's not how KB is set up. They have true vapor pressure thresholds that you can't exceed a TVP of 11.1 PSI. However, so there's not an emission threshold, but there is that vapor pressure threshold, and you calculate your maximum true vapor pressure on a monthly temperature basis. So typically people, you can rely on published meteorological data. AP 42 Chapter 7 has a pretty exhaustive list of metadata sources with monthly temperatures. You can also use National Weather Service data as well to get those monthly temperatures. But ultimately, to determine your vapor pressure for compliance, we're looking at the liquid surface temperature, which we'll talk about in a little bit. And that liquid surface temperature is a function of your storage temperature or bulk temperature, the material in the tank, and the impact that the ambient temperature has on that material. So to your point of what's, if you have a tank or tanks that you're concerned may be having an elevated temperature issue, typically the best course of action is to use your PI data or data historian or thermocouples in the tank to measure your monthly temperature and use that as your average for your bulk temperature. And that will give you the most confidence in making sure your numbers are accurate and hopefully below those vapor pressure thresholds. But otherwise, if you don't have thermocouple data available and you're relatively confident that your tanks are at ambient temperature, AP 42 has, and I think NSPS KB references it as well, the ability to calculate your bulk liquid temperature based on your ambient temperature and different correlation equations for the type of tank that you have. I think I kind of hit, a lot of these storage tanks. Historically, when I first started doing tanks stuff, we had the wonderful Tanks 409D program that existed as a calculation tool, and that no longer is acceptable by the EPA. Back in November of 2019, they published the first update to AP 42. It's effectively now June 2020. They've made some administrative cleanup updates to AP 42 as well. So it's technically June 2020 is the newest date. But really after that November 2019 date, Tanks 409D is no longer really going to be accepted or has not been accepted anywhere. A number of state agencies have come out to say that they're not accepting it for emission calculation, emission inventory purposes, I should say, and it is not a, and there are a number of issues that already existed with Tanks 409 before AP 42 changed. Issues with calculating temperatures above 100 degrees, certain errors in the monthly versus annual formulas, and a number of other things. So from the perspective of calculating emissions from tanks, a spreadsheet that correctly applies AP 42 is a much better option than trying to use AP 40 or trying to use Tanks 409 anymore. Alternatively, there are a number of software options out there that can be purchased or add-ons to existing software packages. Barr has developed a spreadsheet tool that we'll talk about in a little bit. But the important thing is, both from the permitting and compliance side, ensuring the state agency you're operating in is going to be comfortable with the calculation tool that you're using, or more importantly, the calculation tool that you're using can output detailed emission information, all the intermediate calculations. We don't go into the calculations in significant detail in this presentation. In our afternoon air beyond the basic stuff, we kind of start to poke at some of the calculations in a little more detail and see how many intermediate supporting calculations go into calculating the standing losses for a fixed or storage tank. But to that point, if you're relying on some sort of a module, a Barr spreadsheet, other published, other consultants' software tools, it's important to make sure that you have good report output from that, so you can back up your numbers to the agency, whether you're doing a permitting action or just your emission inventories. So another fun one when we're talking about tanks is it a storage vessel? Is it a tank? Those are pretty synonymous to the layperson, but there's definitely a nuance there from the air perspective, right? NSPS KB is specifically written to regulate storage vessels. So this means that there's sort of a generally narrow range of tanks or vessels that it's talking about. So specifically, we're not talking about frac tanks. So those would be portable, wheel-mounted, semi-trailer sized tanks that typically show up to a facility to help turnaround activities, water management, other things. Just because it doesn't apply to NSPSKB, though, doesn't mean that there's not potential emission impacts you have to be mindful of. So even though frac tanks may not have significant regulatory burden, you still may have to consider them from an emissions calculation perspective, construction permitting angles as well. But again, so KB doesn't talk about or doesn't apply to frac tanks, doesn't apply to process vessels or pressure vessels. So there's either, not emission sources. Process vessels are typically a wide spot in the line in a refinery or other facility. That's not what the tank regulations are looking to regulate, but rather the large storage tanks that are holding product. And pressure vessels too are not subject to NSPS-KB regulation, but there are other regulatory programs that impact the regulation of the pressure relief devices and venting of those types of tanks. And then, of course, there's going to be other regulations too beyond just one or two federal standards that may exist for the purposes of tank regulation. So we're still kind of in that same terminal. We've did a deep dive into tanks, even though we just scratched the surface. So we'll kind of zoom back out. And additionally, you've got big old tanks. How do you get stuff to the tanks? Your piping manifold is a network of valves, pipes, supporting pumps along the way that help transfer the facility or transfer the crude or the material through the facility. And what that means is piping components. And that is, again, so we got tanks. The other kind of ubiquitous emission source is going to be our piping components. So what are we talking about? Pumps, valves, flanges, open-ended lines, any sort of LDAR, like leak detection repair program component, we are, talking about from this equipment leak perspective. And when we say leak, there's typically the default emission rate or emission factors that assume everything has a little bit of leakage happening because we unfortunately don't live in a perfect world. So we will have some amount of emissions from all these materials. Connecting and disconnecting emissions from truck loading operations as well. So for these, it's a little bit simpler than the tanks, kind of. I guess depending on the size of your facility and LDAR program needs, it may not be as simpler. But when we're talking about this, the type of facility is important to understand what's in those lines. Is it a gas stream, a vapor stream? What is that going to mean for the purposes of emission calculations? The number of components, that's really the big one and the challenging one. You have field surveys that indicate, actual live reassurable counts of how many valves, flanges, whatever you have in your facility. Do you have, maybe if you don't have a field survey and you've had a facility that has had projects pieced along for a while, you may not have a live current count, but you have P&IDs or other engineering documentation that you can use to develop your deck fitting counts or piping component counts. And then, if you don't have anything that concrete, it's also sometimes okay to do some estimating based on type and size of facility, adding a safety factor. Yes. Mm-hmm. Yeah, that's a good question. The most time I've been engaged in this process, typically we end up working on the construction side, and most of the facilities I've worked with on the permitting side haven't had to go to a full LDAR program. So ultimately what we end up doing is taking those P&ID counts or even a material list from the engineering group doing the design, and then still adding a safety factor of 2, essentially. Because at the end of the day, from a terminal's perspective here, we end up with pretty minimal emissions overall. And from a permitting strategy perspective, it's much easier to permit 100 valves and only install 37 and not have to go back to an agency and say, oh shoot, we permitted 36 valves, but we actually installed 37, even though it's literally pounds of emissions. it just creates a headache for something that's somewhat trivial in the air permitting scheme and often flexible. It needs to be flexible in the facility design construction side of things. So unfortunately, I don't have a good Sure. And I have not done a lot of Texas work myself. No. Yeah, so yep, so there's definitely some, with that added factor, the more you add, the quicker it can go up pretty significantly. So that is a good point in terms of if you have sensitive state regulations and you're relying on a permit by rule or other general state permitting program that assumes you're a very low emitter, make sure that your assumptions are real tight. Otherwise, you can end up in pretty significant non-compliance territory, which we'll have some examples of that too. But that is a good point in terms of if you're assuming you're going to be below a threshold, to do some pretty significant wrangling to make sure people are giving you good information. Because if you're going off something that's not what's actually there, that can cause some problems.
Outside of Texas.
Mm-hmm.
Fire update. Fire update.
Typically, no. Again, from the emissions perspective, the overall bottom line piping component contribution count is typically, again, in like a non-refinery scenario, right? We're talking a gasoline terminal somewhere, a crude terminal. If you're not in the 30, 40, 50 tank range or above, the piping components are typically a handful of tons at best, using safety factor included numbers. And I haven't seen anywhere that have specifically required true-up counts or other direct follow-up on the piping component pieces, because there's also not typically a regulatory program behind these. There may be some NSPS VV or triple GA requirements here and there, depending on your facility, I think. Sure, from the chemical side of things, yes. That is, yeah, I guess I haven't done a whole lot of work on the chemical side myself either, but we haven't seen too much where there's been significant need for follow-up on piping component counts in the sort of northern half of the country where I've typically had projects associated with this type of stuff. Sure. Mm-hmm. Yep. Mm-hmm. Sure. Mm-hmm. Yeah, no, that's a good point. We haven't had a significant pushback. Some of our larger terminals that have had significant PSD-based project impacts end up with an LDAR program as backed, best available control technology, and then that takes care of the actual true-up counts, and we end up with typically lower emissions anyway from the monitored perspective. But in terms of a state permit, easy permitting effort, we haven't seen typically too much further inquiry on valves. But again, that is outside of Texas, and I'm not surprised that that's what we're seeing here, and may be sort of one of the coming waves of future compliance or other needs. It's similar to the fence line monitoring, kind of starting from a California perspective, working into refinery rules, and then now disseminating into other PON-MON type rules or other state regulations as well. So we'll see what that comes up with, because it certainly could be a bit of a rock that hasn't been turned over. But in terms of what we've been seeing from states, there hasn't been a significant pushback on a piping component counts. And most of the time, again, the projects I've been involved with, we get somewhat confident numbers or somewhat confident drawings in terms of the level of detail in not just mainline valves from a block flow perspective, but we can see those pilot valves, those other ancillary sample valves, sample lines with those valves as well. So, right, yep. So it doesn't raise a red flag immediately, and as long as you're comfortably below any program thresholds, the need isn't there. But yeah, if in Texas you're riding the permit by rule program pretty close to the edge, that does create some, yeah, yep. And to that point, just the last one there is, right, the service, depending on what's in it, will impact, the type of emission factor you use, or ultimately the actual monitored emissions from that. A couple general reference points, right? We've talked about LDAR monitoring kind of in these questions. If you're not subject to a formal monitoring program, typically you can apply some type of an emission factor based on your components and go from there. A couple different sources for marketing terminals, for oil and gas production. The factors vary significantly, and it's good to understand the nature and characteristics of the material you're storing, because you can end up with a pretty substantial difference illustrated in this example here. We've got a certain number of valves and pump seals from the marketing terminal perspective and the oil and gas emission factor perspective, and we end up, in the factors here, we're talking in order of magnitude, 2 orders of magnitude on the emission factors. And what that means for 1,000 valves at a marketing terminal, you can have a fraction of a ton, and at an oil and gas facility, you can have 43 tons. Again, that granted, the oil and gas factors are developed for upstream facilities that haven't flashed, have a lot of volatile components. But a lot of times people see oil and gas, think midstream facility, and apply those factors and run into significant issues with the amount of emissions they have from their piping components, when in fact it's not appropriate to use that factor, because by the time you're looking at it from your crude terminal, it's weathered crude, or all the flashing losses have occurred, and you're not going to be subject to those higher volatility materials. Right, so we're kind of, yeah.
I kind of expand a little bit more on why the difference.
Yeah, so the big one is, right, this is from the EPA protocol for leak equipment, or equipment leak emission estimates. I think it's a document from the 90s. The big driver is, if I'm remembering correctly, the oil and gas emission factors are focused on upstream operations, so material coming out of a well. So that's going to have more gaseous components, higher vapor pressure, higher volatility. It hasn't flashed off those gaseous components yet. So that's it's live crude is another way it's been characterized, and that results of those lighter ends being entrained in the liquid, higher volatility, higher emissions. The marketing emission factors essentially are more for refined products, so a gasoline, distillate fuel, or weathered crude oil, in the sense that it's stabilized or dead and doesn't have those light ends remaining that drive volatile flashing activities. Yep. And that's a tremendous paraphrase. If you Google EPA protocol for equipment leak emission estimates, it's a wonderfully page-turning document that has 3 tables people reference and 700 pages of other supporting information that went into the derivation of those numbers. So kind of at the same facility, right, we're going to pivot a little bit to the loading operations. So again, this crude oil terminal we thought was a good example because it had all these parts and pieces. We see our covered rail loading spur here that has the loading arms. We have vapor combustors that control the loading emissions. Some tiny heel and surge tanks. So if they have an issue with the rail loading, or this could be analogous to truck loading as well. If there are issues with loading a tank, loading a tanker, they can dump to a heel or surge tank to make sure they don't have a spill. And there's vapor combustors for emission control. And then again, rail loading can be pretty synonymous with truck loading or barge loading. Again, it's the emission generating activity is around placing product into an empty tank. And then similar to our fixed roof storage tanks, we end up with a situation where we're displacing saturated vapors from a tank, pushing those out into the atmosphere and generating emissions. Unlike a tank where we have a little bit more of a controlled environment, loading operations can be pretty significant if uncontrolled. So we can, when we're talking about loading, we're typically referring to rail loading, truck loading, marine loading. Calculation methods, the most commonly utilized one is also from AP 42 in chapter 5.2. The other things that we need to be cautious of when we're talking about loading operations is not only the calculation of the emissions, but also, unlike tanks, now we end up in the territory where our regulatory programs have specific numerical limits for either destruction efficiency, concentration of vapor at the outlet of your control device, or some other numerical limit that you have to comply with as part of your loading operation. So there's typically stack testing involved. And then another thing to be mindful of is your essentially captured and uncaptured emissions. We have destruction efficiencies commonly given for a flare or a VCU or a thermal oxidizer, but then you also have to be conscious of what your collection efficiency is of your closed vent system, and then also making sure that you account for your uncombusted or uncontrolled emissions as well. To that point, we're again talking about our stored material being loaded into trucks or tankers or something. So we have similar key variables to be mindful of: vapor pressure, throughput, temperature, type of loading. That's a big one for categorizing how significant our emissions are going to be. Splash loading refers to sticking the top of the hose at the top opening of your tanker and just turn it on and letting it splash. Pretty turbulent. Easily volatilizing, creates a significantly higher emission rate than if you have submerged loading, which is if you're loading from the bottom, or make sure that your loading arm or hose is at the bottom of the vessel. So when you're loading it up, it's submerged, it reduces splash and reduces volatility and ends up with lower emissions through that process. The AP 42 chapter 5.2 has different factors for the different types of loading operations and some different vessel considerations to be mindful of. Unloading operations, this is always kind of an interesting one. Typically, if you have a tanker truck, you're unloading it into a tank. That unloading activity doesn't itself typically generate emissions, because we're kind of going in the opposite of loading. As you're emptying a vessel, you're drawing in fresh air. That product is going through a pump, going through a line, and ending up at a large tank, and those emissions are accounted for in your normal tank operations. The one thing we have seen some clients run into is they have what are called air eliminators, or some wide spot in the line that deals with, getting air out or bubbles or eliminating entrained vapors a little bit between the truck and the tank. And those air eliminators can sometimes be uncontrolled. And if they're going right to the atmosphere, that creates a need to evaluate what are the emission impacts from that? Does it need controls? Do you really need it there? Or can you get by without one? Because again, having a gasoline stream or a crude oil stream that has essentially an atmospheric vent as you're moving significant volumes of material can result in significant emissions from an otherwise unexpected or trivial source. Yes.
Collection method, I'm pretty
Mm-hmm.
maybe I have
Mm-hmm.
regarding
Mm-hmm.
people really need to do stack testing. Is stack testing the regulatory or what method?
Yeah, that is a good question. Hoping Tony would be on. We may put a pin in that one. I myself am not a stack tester, so I haven't dealt with that too much personally myself, but it typically can be driven by state permitting requirements. The other thing can be not necessarily, I guess stack test is a general term, but right, there's also the the pressure testing, the closed vent system testing to make sure that there aren't leaks there as well. So in some regards, depending on the control device, you may need to do a destruction efficiency demonstration we've seen in certain states, but not necessarily like always a performance demonstration. It kind of varies based on your regulatory programs from NSPS to MACT and what your states are wanting and the control device that you're looking to use. And speaking of control devices, we'll kind of cover some of the main ones here, right? For the loading purposes, we typically see vapor combustion units or flares, sometimes vapor recovery units as well. So a condensing device or a carbon absorption, regenerative carbon. And technically the floating roofs on a storage tank as well qualify as a control device, though I don't think a lot of people typically look at that in that way. They certainly are if we consider the base case of a fixed roof tank. The floating roof is an intrinsic control device of that piece of equipment. But I think these kind of generally sum up the control equipment we typically see from vapor combustion, whether it be a VCU, a flare, a thermal oxidizer, to recovery units, whether it be carbon or condensing product recovery type of a unit. Anybody seen any novel applications of control devices or questions? Yeah. Mm-hmm. Yep. Mm-hmm. It depends, right? Correct. Yeah, and so there's let's see, the regulatory programs have a milligram per liter loaded limit, often as the threshold that you need to comply with. And whether that's, you can have vendor guarantee information or performance testing to support that, those would be kind of the primary drivers there. The DRE testing we've seen in some states as a compliance demonstration where they didn't have otherwise regulatory programs that were associated with the activities. So it's kind of a mixed bag in terms of where you would see those show up. I'm like I said, not drawing a blank here on specifics. Right. Yeah. Yeah. Yep. And to that point, as we have emission controls, how do we demonstrate compliance with the limits or the thresholds that we're talking about? And to that point, what type of monitoring is needed? In a certain northern state that's very easy to work in, if you have a flare on a LACT unit, your compliance demonstration is a presence of flame. Granted, this is a non-Quad A facility, so it's a legacy facility, but the state is satisfied with presence of flame as their operating compliance parameter. Not the case in all states. Not the case in all situations either. There's obviously CEMS, continuous emission monitoring systems, that can be present for understanding your emission rate, whether we're talking about VOC, NOx, destruction efficiency, parametric monitoring for temperature, presence of flame, pressure drop in a regenerative carbon control system. If you have kind of the big sticking point is especially if you have some kind of CEMS or other significant monitoring device or program, to understand what your reporting requirements are, what your data validation process is, and making sure that you have the right amount of effort associated with managing your data. CEMS data can add up pretty quick. Granted, there's oftentimes quarterly reporting requirements or semi-annual reporting requirements that exist, and it can be a burden on facilities that are already short-staffed to put off CEMS data validation until the end, and it can be a bit of a headache when it comes time for reporting. So it's just if you have either the owner operator or responsible for a CEMS, or you're supporting a client with CEMS type data to understand the data quality procedures and make sure that there's the appropriate amount of effort going into managing that data and making sure it's ready for compliance demonstration use. And then, which is ultimately reporting at the end of the day here. So that was kind of the all-encompassing large terminal with a number of different moving parts. We'll kind of go up or down the pipeline, whichever way you want to go, to our example facility number 2, which is a pump station. And these, for the most part, are pretty trivial. We'll typically see some buildings with pumps. There'll be some pig traps, pig being, I believe the technical term is pipeline integrity gauge. So whether it's a cleaning tool or some other type of smart instrument that operators run through their pipeline to do integrity testing or other analytical data collection on their pipelines. Pig traps, you open them up, you put the pig in, you send them down the line. There's emissions that can be generated from that opening and closing of the pigging equipment. The pumps themselves, depending on their power source, may not have direct emissions. We may just have that piping component situation to deal with. However, if you have a diesel-fired pump or a natural gas-fired pump or other gas-fired pump, we're going to be in a very different situation because these pumps that are driven by, or these pump stations that are driven by electric pumps typically have really low emissions and are below permitting thresholds in most jurisdictions. The pumps, like I was just saying, if they're electrically driven, we just have some component losses to be concerned about. Valves and miscellaneous piping components, again, are going to be pretty tiny. Sump tanks, this can be tricky, and it is really important to know your state regulations. Even though the sump tank may be below your NSPS KB compliance or applicability thresholds, some tanks have kind of sticky rule language that talk about any vessel storing hazardous air pollutant containing material or toxic material, regardless of size, could put you potentially onto a permitting ramp or needing to do more of a detailed applicability analysis. And it can also be difficult to estimate the throughput for sump tanks as well, but typically relatively low emissions. But just because they're low emissions doesn't unfortunately mean you're free from air permitting efforts. I already talked about pig traps a little bit, and then we've got emergency engines as well from the fire pump or electricity generating perspective. So we'll dive into a couple of these units a little more in detail. Emission pathways from a pig trap are essentially kind of based on withdrawal losses, right? As you open that pig trap, you're exhausting a small amount of material based on the clingage of whatever is left in that launcher. So kind of key variables: diameter and length of the pipe that's vented, the liquid properties, number of events. And again, this is primarily from the liquids perspective. If you're dealing with a gas pipeline, the process is similar, but you may end up with pigging equipment being a more significant emission source due to higher pressures and potentially more of a burp of material that comes out of the apparatus. Combustion engine, so this again is from the emergency perspective, from emergency power, fire, water. Granted, it can also apply to the general non-emergency operation as well. The main difference between emergency and non-emergency equipment, aside from the hours of operation, can be the regulatory program requirements and ultimately potential emission controls or other things that need to be included as part of your non-emergency operation compliance demonstration. So kind of cover the categories of engines. Key variables, it depends on what type of fuel they're combusting, what's the EPA tier, and hopefully you have specific emission factors from that engine guarantee that makes emission calculations a little more straightforward. And then hours of operation is probably the big one, right? The EPA has indicated that from a PTE perspective, for an emergency engine, you can you can use 500 hours as your PTE for the purposes of demonstrating that your engine is an emergency engine from the PTE perspective. Obviously, from an emission inventory perspective, you would just use your annual hours of operation. And we kind of touched on emission factors already. AP42 has okay ones absent any information. If you have a generally somewhat recent engine, you should be able to find a spec sheet that has the key emission rates associated with that engine, especially if it's an EPA certified one. And that's the best best bet for your emission calculations, and certainly is the most defensible. And then the applicable standards as kind of a last resort. If you don't have any other engine information, you can rely on what's published in the rules. Yeah.
The hours of
Yeah. Mm-hmm.
It's the 500 hours.
Good question. So this is referring to an emergency engine. And from the PTE, so only the potential to emit perspective, we're talking about 500 hours. So that would be assuming, including emergency stuff and other things. From that worst case maximum PTE perspective, that's where that 500 hours comes from. From the regulatory perspective, right, we're limited to 100 hours total of non-emergency operation, 50 hours of maintenance testing or readiness, or however that breaks down. So the 500 hours here is a little bit separate from the regulatory standard, but rather the PTE representation. So we don't have to use 8760 in a permitting situation. We can say 500 and not have to have it be a synthetic minor limit or take other actions beyond that. Calling an emergency engine with a PT of 500 hours is typically been acceptable. And I can't remember if there's a specific guidance document or, but that's been from the EPA. I believe so. I don't think I have a note on the slide here. Yeah, if Tony hops on, we can circle back to that. But that, I believe, has been the guidance that we've received when discussing this and used multiple times on numerous permit applications for the purposes of emergency engine PTEs. Obviously, if you have a non-emergency engine, you can kind of slice it different ways if you want to limit those hours through synthetic minor limits or other permitting efforts. All right, so we have kind of started way up at the top, gone through our crude oil collection, gathering, loading, transportation, pumped it through the pipeline, hit a refinery, refined it. Now we're sending the material to be distributed. We're at a gasoline distribution terminal, which really doesn't look a whole lot different than our other terminals, just with a different name and slightly different products. We've got large above ground storage tanks. We've got truck loading operations, potential backup generators, some small additive tanks for fuel blending purposes, so ethanol, other fuel stabilizers or materials, vapor combustor for controlling the truck rack, and obviously a whole bunch of piping components. So in addition to the big obvious ones that we've been talking about this all morning, we also, there can be a number of other smaller items to be concerned with from an emissions calculation perspective, and understanding what to do to account for those. So things to consider include heaters, whether you've got heaters on like asphalt tanks or some other heavy product. Are you accounting for those emissions and that impact? Do you have some sort of a treatment process or some other comfort heating that may not qualify for exemptions from state rules? Do you have a significant amount of truck traffic? If you've got loading operations, that can result in some pretty significant PM emissions, particulate matter emissions. Frac tanks, we kind of talked about those. Well, they may not be subject to regulations. It's important to understand what their emission impact may be on a facility level. Are you commissioning or decommissioning pipelines, and are you going to be doing a significant amount of venting in your terminal? Because that can result in some pretty significant one-time emissions that may, again, require some permitting actions. Spills, typically not a major concern from an air permitting perspective, but again, from an EPCRA or otherwise perspective, you can have significant air contributions from a release, whether it be a liquid release or a gas release. Another interesting one is always the malfunctions. Do you have a sunken roof? Do you have a pretty significantly damaged rim seal? There is some guidance in AP 42 and other documents around how to quantify emissions from those situations. Again, that's not so much on the permitting side, but on the compliance and emission inventory side. Unloading operations, we kind of talked on that earlier with potential air eliminators or other efforts. Any other interesting notes or items that folks have run into from emission sources at terminals? I think we've probably drawn a pretty wide pretty wide box. Great. So then we've kind of covered the general terminals, liquid fuels terminals, emission sources, kind of the background and calculations. Now we'll jump into some more permitting focused considerations. So from an air permit perspective, right, we have kind of a couple different ways that states do it. And there's federal permitting, there's state permitting, and within each state, there can be a variety of different pathways or avenues to pursue. Typically we have construction permits and operating permits. We typically, right, from the air world, if you're not an air person, a very important thing to understand is you cannot start construction until you have your air permit in hand. There are many stories of that to maybe talk about later, but from a construction permit perspective, there's sort of the two main thresholds if you're in a state that has construction permitting, and you've got the minor source or state permitting thresholds or programs, and those are typically things you can acquire in a couple months, don't require significant modeling. They're general, straightforward permitting programs to operate in. And then, of course, if you cross over to the major thresholds and you exceed the prevention of significant deterioration or new source review thresholds, you're building a giant new facility or a one-time doubling of your current facility or having a significant addition to an already large facility, you can end up in the PSD, the major world, and that can result in permit issuance timelines of a year or more, relatively complex modeling requirements, best available control technology determinations, and if you're in non-attainment areas, the ballgame becomes even more complex and challenging to deal with those efforts. Other states, you may have a situation where you can be exempt from construction permitting, and you just need to get an operating permit to authorize your facility to operate. Some states have joint permit programs. It's definitely needing to understand the lay of the land that you're operating in and having a strong handle on what the project scope is, what the emission impacts are, what your regulatory program compliance needs are going to be, and understanding how that fits into the permitting world you have to operate in. So for construction permitting, I think I was already kind of teeing up a lot of these points. It's really important for construction permitting to have confidence in your project scope. Not last year, but the year before, it felt like almost every project I was supporting had the clients, and there were multiple clients, all had the general understanding that it's important to start your air permitting process early because the air permit always takes the most time. However, they had almost no engineering done. So we had the luxury of attempting to permit something that was constantly being changed. And I think we're consultant, so yeah, preaching to the choir here. That was somewhat eye-opening to have that happening all at the same time for like an entire year. And then of course, right, typically you can't start construction. North Dakota has a very generous pre-construction allowance for permitting, things you can start, some earthwork and moving stuff before your permit is issued. But it's definitely, if you're in PSD, NSR territory, right, we need to be extremely careful on the pre-construction activities there. And then generally, right, we can hopefully time our permitting efforts to make sure that we're not being the pinch point for project schedules. But of course, that doesn't always happen. And yeah, kind of hit on the design changes, and again, we're all kind of in the same boat here. So this is known quantities. Operating permits, right? State versus federal. Is it? Are you in tribal lands? Are you? Do you have a major source permit? Is it a state program or a federal program? Not always required for construction to begin, but again, it's important to understand, right? Are you going to, meet those qualifications or requirements to not need a construction permit? Sometimes, right, there's going to be, you may need to submit a formal application. Other times, the state will just issue you your permit afterwards. And then, of course, there's all the compliance demonstrations that go along with the permitting process here. So some general permitting notes, just to kind of start to tie this up a bit. Can't further elaborate on the importance of having an accurate project basis and assumptions. Do you need to do some pre-application testing to understand what your maybe kind of aged control device is doing to better understand your potential compliance demonstrations? Are you in PSD territory? Are you doing your analysis correctly? Have you considered aggregating your projects? Have you done that accurately as well? And, you know, and the other one is of course, is your permitting team aware of your project, you know, potential permitting time span? That communication piece can always be challenging, but hopefully folks are becoming more savvy and aware of air permitting impacts and challenges. And of course, are you a major or area source of HAPs, hazardous air pollutants? If you're close, that can trigger, or if you're an area source or a minor source for hazardous air pollutants, there's typically less regulatory program burden to be mindful of. If you're close, is your project going to push you over into major source territory? And are you prepared to install controls on things that may otherwise not need to be controlled? Again, important notes to be mindful of as we evaluate a project for permitting actions. We'll now kind of shift into some unique air permitting challenges that we've kind of seen over the last few years and some hopefully interesting discussion there. So, right, determining physical throughput capacity, you know, how do you draw the box around a terminal? Sometimes it can be trivial if you've got a pipeline in, a pipeline out, and a handful of tanks. But if you have a number of pipeline breakout tanks, perhaps some merchant storage, lacked tanks, different manifolds, different connecting capabilities for your tanks, it can become a non-trivial activity and definitely take time to understand how to represent what that maximum throughput is for your tank. You know, consider using volume-weighted throughput average. You know, don't try to calculate your throughput for a specific individual tank, but try to consider your terminal throughput and then appropriate that to your total tankage to allow for more flexibility in your permitting approach. And really, you know, the important thing is to take the time to do it right and make sure that when you're asking engineers for throughput representations, that you're clear on it being the maximum, the potential to emit, not the hopeful rate or the what they think the average will be, but to make sure everybody's speaking the same language in terms of what's going to be required. It can definitely take some time, but will hopefully help mitigate issues down the road. The other challenge is hopefully that the business development or marketing team doesn't come back, you know, 3 months after getting your permit and say, hey, we actually wanted it to be 10% higher. What do we have to do there? Not that that's ever happened before. So here's, again, a real oversimplification of a facility, right? You've got a 100,000 barrel a day pipeline with a 75,000 barrel a day takeoff, 50,000 barrel per day injection. You've got some storage tanks. You've got some truck loading that has a load out of 50,000 barrels a day. Sort of an example here. So our inbound pipelines, we've got, you know, a total of, for the tanks at least, right? We've got a total of 75,000 barrels a day going into the tanks. And then coming out of the tanks, there's 50,000 barrels a day from the pipeline injection, 50,000 barrels a day from the truck loading, for a total potential outbound of 100,000 barrels a day. But my animation didn't work. The PTE, the bottleneck, the limited PTE appropriate for the facility, for the tanks in this situation, would be based off of the 75,000 barrels a day as the constrained throughput for those tanks. And then ultimately you could, we would typically then appropriate that total throughput based on the tank volumes and average it out that way. So throughput and emission limits, right? Limits may include something on throughputs, typically facility-wide or groups of tanks if you're dealing with a synthetic minor limit or some sort of a PSD project. You can have emission limits on tanks or groups of tanks, and then there's typically the vapor pressure limit that exists through regulatory programs and state rules. The limits are there for those purposes, and the important thing is, right, when we're talking about limits, if we're talking about electively taking on a limit, making sure that the facility understands we can take on a limit to stay minor, but then potentially to undo that limit, it's going to be significantly harder than attempting to permit it at the at the rate that you are wanting to do. And then granted that that response I just gave gets into another challenging question of making sure that you're not splitting up projects from a circumvention perspective, but rather, if a facility elects to take on a limit to stay a minor source, they understand that to undo a synthetic minor limit requires a pretty significant effort and may be much more painful than becoming a major source in today, as it were. And then, of course, if there are going to be limits, whether they're synthetic minor elected limits or regulatory-driven limits, making sure that operations has buy-in or at least is aware of what they have to do, because nobody likes to be given a limit without having at least some amount of exposure and engagement in the development process for how they're going to comply with that. So again, kind of in the same vein of permits, if we kind of zoom into really small stuff, are we adding a few piping components? Are we putting in a new sump tank? Does that need an air permit? And of course, the answer is maybe. It depends on your state. It depends on the type of permit that you have and whether you're allowed to make modifications without submittal or just annual updates. Is there an exemption? Oftentimes, for really small stuff, there may be an exemption based on annual emission rate or short-term emission rates or specific equipment categories. So again, the bottom line note is, don't forget to evaluate and document applicability for any project, regardless of the size, and having good environmental hygiene or whatever you want to call it around who's evaluating projects, and making sure that there is clear communication from not just the major projects groups that want to build 7 new pipelines and 37 new tanks, but also the facility operations guys that are looking to improve. The sump tank outside the lab is pretty terrible and leaking. Let's put in a new one. Great, that makes sense. But do we have to evaluate anything from the air perspective? Non-routine events. Typically, from a permitting perspective, right, we don't need to always be concerned with malfunctions. However, we've run into instances where we've had clients that are developing maintenance programs for pipeline venting or commissioning or decommissioning pipelines at facilities that have permits, and therefore, unfortunately, going through the analysis, we end up having to permit these pipeline venting operations. Vac trucks can be another source of emissions. Texas, right, there's controlled vac trucks. That's not not ubiquitous everywhere yet, but definitely a source of emissions to be mindful of. We've talked about some of the malfunctions on previous slides. Really, it's important to have emission estimates, determine what needs to be put into your permitting applicability analysis, and then does something have to get reported from a malfunction perspective or some other type of a deviation. So I already alluded to the updates to AP 42 a little bit earlier. So they were finalized in June of last year. Key revisions include updates to the temperature calculations for different tank types. The methodology hasn't substantially changed. The equations have just gotten more complex for way of accuracy in terms of calculating temperatures. So again, we already talked about tanks 409D being long since gone, but also to that point, have you or your clients evaluated how you're going to calculate tank emissions moving forward? Are you implementing the correct and most current AP 42 calculations? Do you have all of the family of liquid surface temperature, bulk temperature algorithm equations appropriately mapped out to your partially insulated fixed roof tank, your fully insulated fixed roof tank, your uninsulated fixed roof tank, your pontoon style floating roof tank with bulkhead style floating roof, your pontoon style? There's dozens of equations, which I like spreadsheets. I helped make our bar tool, we'll talk about in a little bit. It was a lot of fun, but it's also very challenging to go from already a mountain of equations to the Mount Everest of, again, it's algebra, right? You're not rocket scientists, unfortunately. At least I'm not. So it's not hard math. It's just a lot of math and a lot of equations to keep organized and make sure they're being applied correctly. So if you have not already supported your clients or your facilities in updating your emission calculations, that's not a bad thing to do off the bat. Granted, I'm not trying to be too alarmist, because really the change in emissions, if you were doing everything right beforehand, the change in emissions with AP 42 is a couple percent, plus or minus 5%, given, all the other variables. So it's not necessarily a situation where you may be over a permitting threshold, but it's enough of a change and it's a different methodology that it's important to make sure you have it done right. There's documentation cleanup to your potential calculation tools, and more importantly, well, many things, right? But AP 42 now officially includes cleaning and degassing emission calculations, and those have been treated very differently state by state. Texas, of course, has some standards already in existence to control degassing emissions down to a certain ppm threshold before you can vent without control. AP 42 now has the effectively API technical report 2568 or whatever it is for initial vapor space purge and forced ventilation calculations from storage tanks. That's incorporated into the new AP 42. So especially since now it's in the publicly facing AP 42 document, we definitely are in a spot where we need to for sure be including it in our actual emission calculations, but also starting to consider it, if not needing to consider it, on the permitting side of things. And that can be difficult because unlike a combustion device emission factor where you have a number that you multiply by a throughput, and you can easily do a PTE or actuals, for the tank cleaning calculations, those are based on measured concentration and flow rate, which is pretty challenging to pull a PTE out of the air from. And you can also experience very different cleaning processes tank to tank, right? If you have one tank that's relatively new, has a cone down or drain dry bottom, you can empty it out pretty easily. You're going to have a pretty quick cleaning process, probably limited emissions. If you have a really old tank that has a bunch of sludgy or waxy buildup, a couple feet of bottoms, it's going to take potentially weeks or months to clean. That uncontrolled, based on this methodology, can have a pretty tremendous emissions impact. And you should really consider emission controls or other in situ cleaning activities before you land the floating roof and begin those cleaning, venting and degassing operations. So kind of bottom line notes, understand your permanent emission limit impacts. Do you have something in your permit that limits your events? We've seen earlier, before the methodology was generally available, some jurisdictions would limit the number of cleaning events you could have in a given year, which provided flexibility for how you could calculate the emissions. But then, of course, you were somewhat limited to make sure that your integrity team was okay with having a fixed number of tanks per year. Other times, there might be just a more traditional emission limit on that cleaning activity. What does your agency want to see in a pre-application meeting? If you haven't, previously had any guidance or engagement on cleaning activities, it may be worthwhile to talk with them up front, just so there's not a surprise at the finish line when you're submitting an application and then they come back with saying, hey, you need to include these. And then making sure that your calculations are appropriate and up to date for this, for AP 42 in general. Yeah. Oh, I'm sorry. Mm-hmm. Yep. Correct. Yep. So the 2006 version of AP 42, Chapter 7, did not include cleaning and degassing emission calculation methodology. The November 2019 to June 2020 updated efforts for AP 42 now includes effectively that API technical report method for initial vapor space purge and forced ventilation. So it is now officially in AP 42, not just in the API documentation. Yep. Yeah. Mm-hmm. Sure. Mm-hmm. Um, I haven't seen those two specifically. Most of the time when I've been involved with loading applications, it's been tanker trucks, AP42 calculation methodology, and associated combustion device control equipment stuff. So we haven't seen too much specific requests for those other, for more details there. I do know that a number of clients who have been in regulatory roles before moving to industry have referenced they often review TCEQ guidance in support of their own state efforts, even though they may be very far away from Texas. So it's, we've definitely seen a TCEQ guidance document influence in other jurisdictions, but I haven't come across specific loading-based efforts in non-Texas areas. So a couple of final notes on emission. This slide is like probably out of date. I would imagine most folks have already used the new AP42 for their 2020 emission inventories. If you didn't, it probably isn't the end of the world, but really for 2021, you want to make sure that you've got the most up-to-date AP42 emission calculations being used for your storage tanks. Again, we've talked about tank cleaning issues in detail. Do you have, the other sticky point might be, however, though, your permit may specifically reference tanks 409D as the compliance demonstration. And that would be something you'd want to look to get updated to AP42 or something where you're not coupled to that old calculation tool that has some challenges with making sure everybody's awake. Sorry. Sorry, Rachel. Okay. So calculation methods, making sure you've got the latest and greatest, because are you required to use an old calculation method for permit limit compliance demonstration? And does that change if you have a really tight limit to, will that couple percent difference make an impact on a permit limit that your compliance demonstration is based on the old AP42 or more worsely tanks 49? So understand what your state requires. Reaching out to your agency can't hurt, just to make sure they're on the same page as you. And oftentimes we found early on the states didn't have a significant stance one way or another. So if you can be early to ask the questions, you can typically find a more favorable solution to managing calculation methodology change. I kind of gave away all the fun stuff. Tank cleaning events, the one thing, right, is the monitoring piece, and have you continued to help your clients or yourselves develop the monitoring necessary to capture those emissions appropriately. Are you going to rely on LEL measurements or base it off VOC concentration? What's your, either one is acceptable in the calculation methodology, but being consistent isn't a bad strategy. And more importantly, you may want to do a couple, trials or experiments where you measure both LEL and VOC and see how those correlate to overall emissions at the end of a single cleaning process. It can be a bit of a hassle to organize and get everybody on the same page for monitoring cleaning event emissions. So it definitely is a big effort if you don't have a process in place, and certainly is something that may need some input. So yeah, begin evaluating the tank emissions on both, or cleaning emissions on both actual and PTE purposes. So this has been kind of a long-term smoking gun. But I think it's still important to reference in light of some other recent EPA documentation. Heavy heated product tanks, so we're talking number 6 fuel oil, asphalt, that stuff that typically has an extremely low vapor pressure and requires heat to be pumpable. Historic AP42, so we're talking the 2006 version and earlier, had incorrect, very low vapor pressure coefficients for number 6 fuel oil, among other things. And that resulted in some facilities ending up with significant enforcement actions because the EPA knocked on their door, did some investigations, asked for some vapor pressure representations, and found out that they were operating under the assumption that they were okay with the old default values and did not need a permit because they were so low. However, the incorrect implementation of, I guess the implementation of bad factors resulted in significant enforcement actions in the neighborhood of hundreds of thousands of dollars, needing to get permits and some pretty significant issues here. So if you've got heavy heated product tanks, make sure you've got a lot of confidence in the accuracy and validity of your vapor pressure coefficient data. To that same point, you definitely don't want to be using tanks 409 for true vapor pressure demonstrations. That's already mentioned in the guidance documentation for the tanks program, but also tanks doesn't do heated tank calculations correctly. It cuts off at 100 degrees. So again, this slide will probably not be here, well, at least the tanks 409 part won't be here next year because hopefully nobody will be trying to use tanks 409 anymore, but there's definitely some concerns if historic demonstrations have been developed based on tanks 409 that you can run into some pretty significant issues. So again, bottom line, is your vapor pressure data good? Are you calculating emissions correctly, both from the data going in, the calculation methodology, and are you accounting for temperature correctly? Okay, modeling, right? We've kind of touched on modeling a little bit. Typically not a significant issue for tanks and terminals. When you hit PSD thresholds, right, we then have to model everything. But, you know, in an everyday situation, modeling for terminals and tanks, I think, is less common in my experience than other emission sources. However, there can definitely be some state requirements from a toxics compliance perspective. H2S and benzene are common ones. Combustion sources, on the other hand, right, those are more traditionally easy to model and typically are going to be larger emission sources, especially for NOx or SO2 or other potential NAAQS, National Ambient Air Quality impacts. And there's the bottom line, right? Don't forget about modeling. It probably won't be an issue, but if you're in PSD territory, make sure that if you're going out for a quote or if you're a consultant providing that you don't underestimate the impact, cost, and time for potential modeling. Yeah. So the most recent stuff I think that's been out there has been more for the organic chemical sector. Terminal wise, I haven't seen anything yet. I know some folks look at it from the good neighbor perspective, where they might do that, especially from like an H2S angle. That I think is the biggest one. Yep. But in terms of more HAP, I mean, H2S is a HAP rate, but more benzene, toluene, BTEX type HAPs. I haven't seen that specifically driven. I mean, fellow consultants, have you guys seen anything from a terminal's fence line monitoring perspective? I think, though, that to the point I made earlier about sometimes things flowing from Texas, California, I believe, has been pushing for a lot of fence line monitoring, I think, for a number of their regulated sources. So I think it may be a matter of time before that kind of makes its way across the country, whether it be from a regulatory perspective or a good neighbor sort of, benchmarking line that we can demonstrate, hey, we're doing a good job and not, or if there is an issue, being able to solve it quicker. So we kind of talked about major and area source from hazardous air pollutants a while back, a couple slides ago. Many facilities, especially from the gasoline distribution terminal perspective, were originally permitted as synthetic minor sources to avoid PSD to avoid major source status because of HAPs. We're talking back in the 60s, 70s, or not 60s, 70s, 80s, 90s. Since then, methyl butyl ether, a gasoline additive that was a pretty substantial HAP, has been banned, and therefore the potential HAP impact of gasoline terminals is reduced significantly. So we've seen a lot of folks looking to take advantage of the once and always in policy reversal changing to become area sources again and get rid of their major source HAP status. And let's see. So you may not need a permit limit anymore to avoid major source status. CAM is kind of a catch-all because we thought it would be good to mention CAM in an air permitting perspective. CAM is continuous, oh boy, I'm blanking on it. It is the monitoring requirement for rules and regulations published before modern regulatory monitoring rules existed. And oftentimes it might be at some kind of a control device, but typically, if you're not a major source anymore, you're not going to be subject to CAM. You're not going to have the same, potential limits or other significant programs to be in compliance with. You can get yourself a much simpler permit. Again, kind of rounding out some of the air permitting topics. We've got attainment status and national ambient air quality standards. It can have a significant impact on permitting. Are we talking about, backed instead of, or layer instead of backed lowest achievable emission rates or best available control technology? Emission offsets. If you're in an area where the designation has changed, you may have to apply for a new permit even if your facility itself hasn't changed. And then of course the challenge of emission offsets can be costly as well. A couple of recent ozone redesignations have occurred and have definitely had impacts on some of our clients' projects. Okay, we have approximately hit the halfway point. So we'll take a break here for about say 10 minutes, be back about 9:50, 9:52, somewhere in there, and we'll pick up with a few final closing thoughts on air, and then I'll finally take a break, and we can talk about water and all the other fun regulatory programs.
You there, Rachel?
You gotta go with the mic there.
Oh. Can you hear me? Hello in there? That's kind of echoey. Echo. I'll turn the volume down. Just talk back here. She's not there.
All right, we have hit the end of our break here, so we'll pick back up for those that have returned. All right, so I may have lied a little bit. I've got a little bit more air stuff to talk about because there's never enough air. And then we will shift gears to the multimedia world. So documenting regulatory applicability, I think we've touched on permitting a whole lot up to this point. But what about new regulations? We've talked a little bit about major versus area source of hazardous air pollutants. Is a new project bringing something new on site in terms of emission unit or equipment that would trigger new regulations? Have you never had a emergency generator or diesel-fired pump on site and you're bringing one on and now you're subject to the RICE rules? Understanding not only your permitting impacts, but also your regulatory compliance. Make sure that we've found a good tool to help our clients with is a permitting decision record file. So as we're able to engage with their design teams or be involved in those meetings, helping support the documentation around project scoping, why we chose this specific size or designed unit versus this one because of these XYZ air reasons or operating reasons. That can go a long way when suddenly 5 years down the road and you're either working with a different firm or your department is turned over, you can understand why this project happened the way it did and not have to extrapolate too much. And then memos to file are always beneficial. I think it's a balance of, is it an email answer or do you take the time to write a couple pages? That can go a long way in terms of, again, providing that documentation. In the flash drives that I have slowly loading with our presentation material, we have a couple handouts, and one is a potential regulatory applicability documentation tool that you can take a peek at. I've alluded to a lot of these already. We'll touch on them in a little more detail now on the regulatory program side. So from the federal perspective, right, we've got New Source Performance Standards, NSPS rules, Part 60. This regulates criteria pollutants, applies to the affected facilities as defined in each subpart. So these rules talk about specific pieces of equipment like storage tanks, engines, flares, sulfur recovery units, et cetera. And then there can be different classifications. Are you constructed, such as you're building something new? Are you modifying something, which means you're increasing the emissions rate? Or are you reconstructing it, meaning you're changing it such that you increase the cost of the project associated with the piece of equipment is 50% or greater of the applicable reconstruction cost threshold. So there's a couple different ways you can kind of end up in NSPS rules, and within those NSPS rules, there can be different thresholds for modified or reconstructed units depending on dates. And in general, each subpart covers standards for emissions or operating limits, testing and procedures, reporting, monitoring, record keeping, all the standard regulatory stuff to demonstrate compliance. So again, from the air perspective, the NSPS New Source Performance Rules, what we typically see for terminals and storage tank facilities, subpart A is the general provisions. This is the how to and where to submit notification type stuff. General testing requirements, sort of the miscellaneous applies to everything in some capacity stuff. More specifically for storage tanks, there's the K series of rules, K, KA, and KB. We typically, if you're building new stuff, you're only going to be subject to KB. These are based on the date when construction happened, essentially. So you may have some legacy K, KA tanks in your area, but those we won't ever see new tanks subject to those rules. Subpart XX deals with bulk gasoline terminals, primarily the loading racks. That's where we get some of the emission control standards for those. Subpart 4I and 4J are the RICE rules, reciprocating internal combustion engine rules, that cover the emergency and non-emergency provisions for diesel and gas-fired engines. I always find it interesting. I've always referred to them as 4I and 4J, but then we get this subpart Quad O and Quad OA. That is the vernacular, I guess, for those terms, or for these rules. Quad O and Quad OA, crude oil, natural gas facilities, kind of in the upstream segment, has specific provisions for storage vessels as well, in addition to a number of other upstream piping component, compressor, and other equipment there. Kind of shifting from the NSPS rule set to the Part 61 rule set, which is the National Emission Standard for Hazardous Air Pollutants, or NESHAPs. These were the first regs that covered hazardous air pollutants, and there were an initial 8 of them. Applies based on activity performed and HAP you may emit. So unlike the NSPS rules, the NESHAPs are based on your industry or operational activities. And really, from a terminals angle, the big one is subpart M, the asbestos rules, dealing with the demolition and renovation of old buildings. Pipeline installation is going to be a big asbestos source, especially for old facilities. So it's sort of an air rule, but really more of a materials management perspective there. So then the Part 63 NESHAP rules are more colloquially known as the Maximum Achievable Control Technology, or MACT rules. So these regulate hazardous air pollutants beyond those original 8 in Part 61. Again, it applies on industrial classification. So again, we're talking about refineries or iron ore processors or microchip manufacturers or chemical manufacturing plants, not just one specific piece of information, but in those rules, of course, they cover all the different potential emission sources you may have. Standards exist for both existing and new sources, so you may be subject to a specific rule, and then you change your facility, and you're still subject to that rule, but now you're subject to the new standards. The existing standards can typically be less stringent, and then the new rules, or the new standards under that same rule, are more stringent, assuming you have more modern and effective control technology and other factors. And then there's, under the MACT rules, without making it too confusing, there are both major and area source MACT rules. So depending on your HAP classification, you may have a number of different but similar rules. The one that comes to mind would be like boiler MACT, which is for the area or major sources. And then there's the area source boiler rule as well. So here more for tanks, however, right, we've got, again, subpart A, we're talking about our general provisions that apply across the spectrum for the universal items. Subpart R deals with gasoline distribution, covers loading racks, storage vessels, equipment leaks. Subpart Y specifically covers marine loading operations. Subpart SS is the closed vent system. So if you have a fixed roof tank that has a vapor pressure in excess of the typical thresholds, or has a certain HAP emission rate that's too high, you may be required to install a closed vent system to collect those vapors coming from the tank, and a control device of some kind to destroy those emissions, and that information is contained in subpart SS. Subpart WW is the effectively MACT equivalent of NSPS KB. It has some slight additional control requirements for your deck fittings, and it also has, which we'll talk about in a minute, additional provisions for doing your 10-year internal floating roof tank inspections while your tank is in service rather than taking out of service. So that's an important one we'll come to in a minute. The other, we talked about subpart 4E earlier as well, organic liquid distribution, but we're not talking about gasoline here. So that's, again, storage tanks, transfer racks, equipment leaks, all that stuff. Subpart 4Z is the MACT element of the RICE rules. Subpart 6B is the gasoline distribution, bulk terminals, bulk plants, and pipeline facilities. Again, all of these rules are effectively doing the same thing to regulate and manage emissions from terminals, tanks in the petrochemical sector. Some other things to be mindful of, the acronym I forgot, Compliance Assurance Monitoring, is Part 64. Again, this applies to facilities that may be subject to a rule where you have a compliance demonstration that's not baked into your regulatory program. I believe it typically is for rules that were promulgated before the 1980s, I believe. There's also some chemical accident prevention provisions in Part 68. Part 80 has the fuel additive regulations. Part 82 is the stratospheric ozone rules. And then Part 98, the mandatory greenhouse gas reporting. This one is a big deal across a lot of industries, but it's kind of hit or miss from the terminal angle, depending on how much combustion sources or other specific greenhouse gas impacts you may have at a terminal. Which isn't to say, though, from an ESG perspective, you may be looking to account for and quantify greenhouse gas emissions from your terminal activities. But for Part 98 rules, it's typically not too common. The other tricky part is if you're co-located with another industry, especially like a refinery is a common one, there may be other rules that reach over from the refinery to your terminal since you're co-located as a single stationary source, which can include triple Q for wastewater systems, subpart FF, better known as B1, the benzene waste operation Nishap, and then also parts CC, the petroleum refinery rules as well, which would potentially reference MACT WW. So that was kind of a whirlwind of federal regulations, just as kind of a primer for what we need to be aware of from the federal perspective. And it could be, you know, one or two of them, or it could be a laundry list of them. So it gets back to being knowledgeable on how and where you have documented your applicability and the approaches you've taken there. On the flip side, of course, we don't just have federal regs, we've got state regs. Many states have regulations that are more stringent than the EPA requirements, and Texas being a prime example, California being another one. Some, just for fun examples here, North Dakota has specific guidance for non-production storage vessels that deals with when and where you need controls. Colorado has had a number of significant regulation changes over the last couple of years and is still dealing with a number of changes to their regulations right now as well, especially in the oil and gas sector. And Wisconsin has kind of a fun one that we wanted to point out. Tank surfaces must be white. So they have in their tank regulations for Wisconsin, even though NSPS KB, MACT WW don't have specific tank color provisions, Wisconsin state regs require your tanks to be painted white. And that's beneficial from the, you get better, you know, your tanks don't heat up as much, you have lower vapor pressures, lowers emissions, but it's a specific Wisconsin rule that some other states have as well. So it's, you know, knowing again, do you want to have an unpainted tank that can save some costs in your, you know, project budget, a couple $1 million, depending on the tank size, but you could, that might not even be an option because you're required to paint your tank white. Interestingly, another challenge with Wisconsin has been historically, before the changes to NSPS KB that allows us to elect MACT WW compliance and do our 10-year IFRT tank inspections in service, we now are stuck in Wisconsin. They require the 10-year IFRT inspection to happen when the tank is out of service. So even though we have federal regulatory avenues to pursue out-of-service tank inspections when the tank is in service, there's still some Wisconsin rules that are being figured out, and we've been in contact with them after the change to NSPS KB, and they're apparently evaluating the issue, and we'll see what they come back with. Couple other notes on Texas, just kind of from an overview perspective, right? We've got general rules. They've got their MSS updates or MSS rules. We've got a pretty significant permit by rule sections on the MSS activities, oil and gas, tanks, turbines and engines. Controlling air pollution from volatile organic compounds. Again, these, I'm not intrinsically familiar with all of these. However, it's just, again, an example to show that when we have, you know, we can have all the federal permitting and compliance stuff figured out, and there still can be a pretty complex state level compliance program that we have to work through to understand what's going on. So air permits are going to be the overwhelming source of limits of compliance requirements, compliance demonstrations. Regulations are going to be the typical source for a lot of the compliance requirements that we have to do for monitoring, testing, and everything in between. But we also don't want to forget about, you know, besides the regulations, what's in our permit? Is there a condition we accepted from some sort of a limit? Is there a state rule that that's been worked into our permit? Do we have specific backed limits that require additional controls on our storage tanks? Is there a consent decree, right? I don't think we see too many terminal consent decrees, but in the refinery world, that's a pretty common tool that has been used to regulate and enforce and add additional to-dos to a refinery's compliance demonstration. So again, just being mindful of a variety of sources where other compliance or air quality regulatory activities can come from that could be impacting your terminal. So kind of taking all the air topics that we've covered, they start to tie it up a little bit. Things to help you comply and understand what what all is going on in the air world. We found success in helping clients develop what we call a compliance action plan, or some sort of a universal document that combines all of your regulatory applicability, permit information, deck fitting inventories, miscellaneous equipment, insignificant activities, all your air stuff we try to put in one spot, so that it's a useful, big document. Get it to the relevant people. It helps drive air permit awareness beyond just your environmental staff. And so that compliance action plan document, we've found success. I will have flash drives, hopefully with my computer working here shortly, that'll have these examples and the presentation on them. So make sure you stick around before you go to grab those. Additionally, though, we've talked a lot about emission calculations, and it's important to have something that's useful, that you can either have a reliable consultant or team member that can run tank calculations. If something is going on with your vapor pressure limits or thresholds, you can model some scenarios. You can see how close you are to permit thresholds. Are you using a spreadsheet? Are you using other software without sounding too repetitive? Making sure you've got confidence in those applications or tools that you're using, because we don't want to have false confidence in, the numbers look good, without understanding what's happening behind the curtain in the black box. That can result in some pretty significant issues. A compliance calendar is, we've seen some clients that have a spreadsheet, and we've helped them modernize that process a little bit. We have folks that we help run a database tool with that pushes out notifications with schedules and deadlines to make sure that they're seeing their environmental tasks in real time to act on them without being reactive to them. And then, inspection forms and templates. We want to make sure that there's good documentation and good programs in place for when we have to do seal gap inspections on external floating roof tanks, or doing the out of service 10-year inspections. We're getting the information we need and maybe some more for environmental purposes, and not just trying to rely on forms that are from the operating group or somewhere else that only halfway cover our environmental needs. So it's good to, again, think about our tank inspections not just from the integrity perspective, but from what we need for air compliance demonstrations. So again, in talking about all those things, right, we're just kind of tying it up. We've got design requirements for the tanks. We want to make sure our tanks are designed correctly, that they have the necessary rim seals, necessary deck fitting controls. Do we need emission controls on loading operations? Do we have limits? Are those limits communicated to the key stakeholders? How are we tracking them? Are we calculating them midway through each month? Are they, do they need to be looked at on a weekly basis? Is somebody not looking at them at all and being reactive to them in the semi-annual period? Who's responsible for scheduling and coordinating inspections? Are they, again, is it a trust but verify situation, or do you have a well-oiled machine, or is that something that needs some time and attention? Testing, typically, right, we don't see a whole lot of testing from a stack testing, performance testing perspective on tanks. It's pretty difficult to do. The API documentation, if you really want to have fun and spend money, you can attempt to test your own deck fittings. There's guidance in the API documents on how to develop site-specific emission factors, though I don't think anyone has ever done that, but the information exists. Again, but testing may apply to heaters on site or control equipment. Work practice standards. Do you have either an informal LDAR program for AVO type emissions or AVO inspections, or do you have a formal LDAR program? Do you have a good program with your LDAR provider? Is that being managed well? Record keeping, reporting, notifications. Again, all these kind of can roll up into compliance program management stuff, or they can be separate individual things that create some amount of chaos depending on how many people are involved. So as we sort of transition to the next couple parts of the presentation, we'll be covering some of this in more detail along with the other media here. That in mind, here's kind of the home stretch on air stuff. Just a few compliance challenges we've come across with various different activities that we thought would be good to share here. So we've hit on tank cleanings and the challenges around emission calculations for tank cleanings, the fact that they're still sort of new and being understood, but also just from the perspective of the out-of-service tank process, or non-routine events, as they're also referred to. We have both the landing of a floating roof tank, the cleaning, and the refilling, and we need to be mindful of record-keeping requirements that exist through our regulatory programs. So we need to know when the tank landed, be able to show and demonstrate records that it happened, that we know it happened, or if it happened and we didn't know it happened, we still have an understanding of when it occurred and are able to collect the information we need to potentially report anything. Do we have any compliance limits that we need to account for in terms of, can we only land this tank 2 times a year, and are we going to run into issues with that? Emission controls, this is less about the landing and refilling part, but definitely cleaning can be a major concern. Do we have a permit requirement to control our tank cleaning activities? And or do we have neighbors, and if we're going to have a lengthy kind of sloppy cleaning event, do we want to elect to install control or use controls to manage odor and prevent nuisance odor issues? Emission calculations, we've talked about AP 42 quite significantly. Bottom line, right, keep records, know when you land and clean a tank, and make sure people that are operating the tank know that it's important that you know that, again, assuming you're an environmental manager or responsible for tanks. And be prepared to calculate, permit, and report cleaning events if you haven't already. Vapor pressure determinations, historically, right, we're talking crude oil, gasoline, refined products. We typically get by with an RVP, and that's been easy and useful, RVP 9, RVP 10, RVP 5. But for crude oil, that the ballpark, the ball game has changed a bit in that there's, I don't think we can call it new anymore, but ASTM D6377 is a specific vapor pressure determination method that does a much better job of capturing crude oils that have lighter ends and gives a much more accurate representation of volatile crudes at higher temperatures than just the RVP correlation would in the past. So if you have crude oil terminals and tanks, definitely look into that ASTM method if you haven't already. Refined products, there's a laundry list of other ASTM methods that can better calculate and determine your vapor pressures as well. But in terms of kind of the big one is the ASTM D6377 for crude oil. Interestingly, right, does the state allow it? We need to be careful of what is written in state and federal regulations to make sure that there's provisions to, typically the federal regs are written that, here are things that we can use for a vapor pressure determination, plus anything that is new or further defined as a useful test method. Some states, however, have really prescriptive, not very flexible language around how to or what you can use for vapor pressure determinations. So it's important to be mindful of not only the federal allowance to do so, but is your state going to have a problem with the newer, better approach to vapor pressure calculations? Let's see. So yeah, again, if understanding what your state regs are, understanding what's listed there, and being able to pose some questions early on if you need to is going to be helpful. Another kind of more challenging one, depending on if you fall in that midstream to slightly upstream perspective, is do you have NSPS Quad O A applicability at your terminal? Do you have like a 400 barrel LACT tank, adjacent to your facility? It depends on your PTE, right? The Quad O A thresholds are PTE based for the tanks. So if you have a small tank, you may be able to easily show that you're outside of the quad A applicability. But it's one of those things where it's not just an easy slam dunk, no, this doesn't apply to me because I'm in the midstream. So again, if you have potential tanks in that transportation sector, upstream transportation sector, and you haven't looked closely at quad A, it's definitely a good thing to take a look at if you haven't already. We've covered on this one, but I think it is really important from a compliance perspective to have a solid understanding of your tank deck fittings. We have, before we were able to start helping, a client had an issue with a specifically uncontrolled deck fitting that needed to be controlled and was pervasively uncontrolled for a number of years. Not that they knew it, but it was sitting uncontrolled, and they were levied with a tremendous monetary fine along with a bunch of other scrutiny because of some uncontrolled and unknown that they were uncontrolled deck fittings. So that really, it's pretty trivial. Does it have a gasket, right? That's a simple question, but in terms of managing a dozen tanks or 100 tanks across multiple facilities, it can become a challenge to make sure you've got a good handle on your deck fitting, tank design, inventory. So we really try to push for, having a robust program around understanding when a project is happening to a tank roof and is something going to change and what's going to be installed or what's going to be new. Is it going to be able to meet the necessary control requirements? Will other deck fittings need to be updated because now this tank is subject to a regulation it wasn't before? It's pretty easy to lose track of, this was a legacy tank. It had, ungasketed access hatches. Nobody thought twice about it. And we installed a new vacuum breaker because we needed better venting to comply with the API standards. And now it's subject to KB. And nobody in the environment group was made aware of this. And now we have to gasket our access hatches, and we haven't. And oops, can we self-disclose that before we get in significant trouble, or will it go unknown for a very long period of time, and then we'll have to deal with the challenges that way? So, as trivial as deck fitting stuff can seem, it's really important to make sure that the stakeholders have a strong handle on what is there and what they need to do, and how to manage change with that as well. Speaking of vacuum breakers, another trivial but consequential one is for tanks that are subject to NSPS KB, MAC WW, your vacuum breakers must remain closed while your tank roof is floating. And we've seen operators have issues where their vacuum breaker legs get stuck open because of some gunky buildup or in the mechanical leg area, and they have vacuum breakers that open when their roof isn't landed. And we're talking about pounds of emissions, but we end up running into a compliance concern because their permit condition says thou shalt have your vacuum breakers closed except for when you're landing the tank. They now have deviations that have occurred, and it's managing the trivial stuff to make sure you get it right. And do you have appropriate inspections and communications set up that you can capture these things when they happen, or are they happening unbeknownst to anybody who understands an air permit? Again, kind of on the floating roof tank operation, right, beyond vacuum breakers, the regulations typically mandate that the fill and refill must be continuous and rapid as possible, especially for the filling process. You don't want to start to fill a tank, get 3 feet of product in there, stop for a couple days and start to fill it again. That has a pretty significant emission generation element. And the nature of the rules are to have your tanks floating or out of service. So we don't want to delay that filling process. For emptying a tank, right, we can empty it down, and there can still be typically some product in the tank as long as we have it drained to puddles. We don't have to have it, immediately cleaned and spot free to be in compliance with the KB regulations. You still may have landing, standing, idle losses, but if your tank is out of service and as emptied as you can, that typically accommodates that, especially if you're moving into a cleaning process. We don't want to end up in a situation where you're landing a tank, the roof legs are like 6 feet and you've got 2.5 feet of product and you're going to let it sit for 2 months. That is a situation where there's going to be some KB compliance concerns, because that definitely is not transitioning to a out of service or cleaning state or refilling state in a rapid manner. So make sure you understand how your vacuum breakers are set. and make sure your operators know when and how to land tanks and how to manage product in a tank once it's landed and what kind of the expectation is around timing. Kind of staying in the modification, the NSPS, the deck fitting vein, older tanks can trigger KB if you change stuff on the deck fittings or the rim seals. I think we've kind of spoken to this example a number of times already, but more specifically, there's not a de minimis level for emissions increase for an NSPS modification. So if you add the most trivial of emitting deck fittings to a tank that's not subject to KB, that will put you on the on-ramp to compliance there. Reconstruction is based on cost and not emissions increase. Oftentimes triggering modification or reconstruction for a tank isn't a big deal. Most deck fittings can have a gasket installed pretty easily, or bolts or some sort of fastener installed. The slotted gauge poles can be a little bit tricky sometimes with the emission control in the sleeves, but it's typically not an issue except for when it happens at the last minute or isn't communicated well. So again, communication, much like in everything, is important. Being aware of on-the-fly changes is another one. Is something happening at the last minute at the end of an API 653 integrity refurbishment project that wasn't communicated? And oh, it might be good to throw a vacuum breaker on that access hatch. Let's do that now before we fill the tank. Sure, but has that been communicated? Is there a permitting impact? Is there a regulatory program impact? Bottom line, environmental stakeholders need to be involved in the tank evaluation process to make sure we don't have any compliance trigger issues. Again, this is kind of just making sure I didn't miss anything in the previous conversations. Floating roof tank inspections, often left to operations, maintenance, or someone else outside of environment doing the inspections. Are they trained? Do they have the appropriate knowledge and forms to document everything that the environment side needs from a tank inspection? Oftentimes, there's overlap between what maintenance is looking at and what the environmental inspections require. However, it's not a perfect overlap. We've seen some API 653 integrity inspection reports that do a good job and could pass as a out of service NSPS KB inspection, and other ones that have not. So it's really important to have alignment on, who's inspecting, what are they, what is the purpose of that inspection? Do we need to have a specific or separate environmental inspection? And making sure that, again, stakeholders from environment, operations, integrity, whoever is involved in supporting inspections, especially if they're environmentally driven, have the proper understanding to do it right and get the right data documented. Another kind of fun, maybe less of a boogeyman now that it's been around for a while, item to note, right, are the FLIR camera inspections. Optical gas imaging. Regulators have been more actively using these tools to observe facilities from the fence line and see, oh, that tank looks like it's having significant emissions. There clearly must be some type of a situation going on here. Let's have an impromptu inspection. Let's figure out what's going on here. It's a useful troubleshooting tool from a facility perspective as well. You can use them to kind of do some internal auditing. There aren't quantitative FLIR yet. I think there might even be some folks here that are talking about more better, improved optical gas imaging. But in general, right, it can show us a gas plume. But the bottom line is tanks are designed to emit as well, right? We're not talking about completely sealed systems. So just because a tank is emitting on a FLIR camera or an optical gas imaging camera doesn't mean that we have a compliance issue. It could be the tank is being filled, the tank is being, appropriately landed, or the tank has all the vacuum breakers stuck open and it's been sitting there for 6 months. So having robust documentation of your emission calculations, inspections, other compliance requirements to then show that, yes, our tank is emitting, but here's our compliance. We're doing everything we're supposed to do. The tank is fine to emit. That's what they're designed to do. But being able to answer that question with documentation, calculations, all that stuff, rather than just saying that's what it's supposed to do. A fun comparative exercise here. Delta Western in Alaska was a bulk gasoline terminal, and then Lincoln Terminal Company in Chattanooga, Tennessee, One had an air permit violation, one had an EPCRA violation, and there's a pretty significant zero significant figure order of magnitude difference in enforcement activities. Granted, not to belittle EPCRA programs versus air programs, but typically we see the most significant and substantial monetary impacts with air permit issues. Granted, there can be some pretty substantial TRI related fines and enforcement actions as well, not to exclude those, but oftentimes the air programs are the ones that are going to be the most substantial. So again, it pays to do it right the first time versus paying to learn you did it wrong and then having to pay to do it right. Boy, I think we've talked about this plenty enough. Maybe with the last note on how to monitor, because that's the biggest one. The calculation method isn't complex, really. It's just a matter of how are you going to collect your data? What resources are you going to rely on? Are you going to get out there to hold an instrument yourself? Are you going to rely on an LDAR tech, the safety crew, a data logging station? With the way the calculation method is set up, it's difficult to adequately estimate a PTE without collecting good data, and tank cleaning events are going to differ event to event, so that becomes a challenge on developing something for a PTE. So again, a couple of different ways to slice it. It's important to start having those discussions. Kind of rounding out here, some relevant applicability determinations and alternative monitoring plans. We would see in the past a handful of tanks getting AMPs for conducting their 10-year IFRT out of service inspection in service. And then the EPA between 2018 and 2020 essentially kind of stopped issuing them significantly. There were a couple that came out, but there was rumors of a NSPS, a universal AMP that they might have issued to cover things. And fortunately, possibly, instead of that, we have at least the new alternative NSPS KB compliance option, where you can elect to comply with MAC WW, which allows you to do the 10-year inspections in service. So that is a bit of an improvement there. And then of course there's common AMPs for control device monitoring situations as well. So speaking of KB and the alternative control option, generally it's good. You don't have to land a tank just to do an environmental inspection, because then it would generate more emissions to do an inspection for the purposes of reducing emissions. But the challenge is you can elect to comply with MAC WW, but you effectively take on all of MAC WW's compliance demonstrations and requirements. So you can do your in-service inspections. There's clarification that the 1/8 inch gap standard is only for deck fittings, not rim seals. That was some ambiguity in previous AMPs. There's slight differences in deck fitting controls though, like stub drains and automatic gauge float wells require controls that may not specifically align with NSPS KB. And there's some notifications to submit to kind of get on the on-ramp for that as a compliance tool. But the bottom line is, if you can safely and completely perform the inspection with the tanks in service and meet the MAC WW requirements, this is a pretty big win. If you can, again, get the safety crews and everything needed to do those inspections and see your rim seals and all that stuff while the tank is in service. And that is the end of the air section. So I will turn it over to Rachel and we can keep rolling.
I will start by just a couple housekeeping items, given I'm presenting remotely and I'm not able to see if there's hands raised. So if you do have a question, I do encourage that. Please let Al know, and he can do the raise the hand function in Teams, and I can stop and take that question. And I will pause periodically and just confirm if there are any questions so that we can address those as we go. Next slide, Al. We'll start by talking about the National Pollutant Discharge Elimination System, or NPDES, as it relates to terminal facilities. Next slide, please. From a very high level, the basics of an NPDES permit program is that they're authorizing and regulating the discharge of pollutants from point sources to waters of the U.S. or state. So there's a lot to unpack in that initial statement. Discharge of pollutants, that is a pretty clear way to understand, you are introducing something to the environment. Point source has a little bit more nuanced definition, that it's essentially any discernible or confined or discrete conveyance where you're discharging pollutants. And there's been a recent case within the U.S. Supreme Court looking at discharges from a wastewater treatment facility on the county of Maui in Hawaii, that they use groundwater wells, and that groundwater eventually goes to the Pacific Ocean. And the court determined that, well, that was not a discharge directly to a water of the U.S. or state. It was a conveyance, essentially, and so that would a functional equivalent of a direct discharge that required an NPDES permit. So, how that has some applicability to terminals potentially is, if you've got wastewater, stormwater ponds, septic systems, or other type of shallow groundwater injection, spray fields and land application, or industrial stormwater infiltration features that maybe previously weren't considered under an NPDES permit, may now require it if there's a functional equivalent of a discharge to water of the U.S. So just something to keep in mind there. The second thing on that statement of waters of the U.S., for those of you who may be familiar with this set of regulations, the definition of waters of the U.S. has been on a roller coaster for many years. Most recently, the rule that came into effect in 2020 gave a definition of waters of the U.S. under the Trump administration, and now the Biden administration is looking to revise that rule. So what is waters of the U.S. is going to continue probably to change again even after that. So if you have questions about that, maybe we can take that separately, because it could go in quite a bunch of different angles. So if you do need an NPDES permit, they're typically issued by either the state, territory, in some cases the tribes, or EPA, if they have if the tribe doesn't have authorization within their bounds. They're typically issued for a 5-year period. However, in some cases, submitting a timely renewal application, the agency doesn't always get that issued in 5 years. So it can become what's called administratively continued until the agency does issue that authorization. And before you were to do any modifications to your facility or process, that if you are introducing new pollutants or increasing the potential pollutant load, you may need to get a modification to your permit. Next slide. So there are 4 types of NPDES permits currently available. They're considered wastewater, so that is your typical processed water. The photograph here showing the stereotypical pipe discharging from a facility. Industrial stormwater is, where you've got contact of stormwater to potential pollutants at your facility. Construction stormwater would be more if you have a maintenance project or an expansion happening and got contact with those exposed soils. And then lastly is a publicly operated treatment works. And why we mention that here under this discussion is that in some cases, if you have wastewater, you could be discharging to a POTW if you have an agreement with them and that establishes the standards that you need to meet. So you might have to treat for higher levels of benzene, for example. to meet their requirements, but then also make sure that you aren't stepping into some of the waste considerations under EPCRA that Greg will talk about a little bit later. Next slide, please. So we'll start with wastewater. Some of the typical types of wastewater at a terminal facility might include tank bottom water. If you are cleaning a tank or you have water in the bottom of the tank. Petroleum contact water, that could be from a loading or unloading rack, for example. Secondary containment, if you've got a secondary containment berm around tanks, if there is exposure to petroleum materials in there, it could be regulated as wastewater under NPDES. And hydrostatic test water, both for tanks and for pipelines, if you intend to discharge that at your facility. And so a note here is that not all facilities do have wastewater. And some may have all of these things. It can be unique in every situation, and especially if a facility is pipeline in and pipeline out, or regulated by the DOT and does not have sources of wastewater. It may just be NPDES may just come up for construction, and we can talk about that a little bit later. Next slide. Wastewater discharge permits are typically going to include all of the items listed on this slide. We're going to have effluent limits for those wastewater discharges, usually on a maximum or average rate, and giving frequency, either that's daily, monthly. They can be, both numeric, like a maximum concentration of 15 milligrams per liter for oil and grease, or a narrative that it says, must be free from visible oil, color, floating solids, foam, etc. Typically are going to have monitoring requirements. If you do have effluent limits, collecting samples and confirming that you are meeting those limits. Inspection requirements are, more making sure that the facility controls are operating as intended. So that would be taking a look at your containment areas, oil water separators, if you have control technologies or best management practices in place to manage your wastewater, that those are functioning as they need to, and that if they're not, that you're making provisions for repairs. Some wastewater discharge permits will also include hydro test discharges, unless, in your particular state or location, that's handled under a separate permit. And those are typically going to have some of those same limits for flow, monitoring discharges for specific parameters, inspecting for sheen are typical requirements. If your industrial stormwater is not covered somewhere else separately, that could be covered in a wastewater discharge permit as well, and would have some of the similar requirements under a stormwater pollution prevention plan, and we'll cover those typical requirements in a few slides. There could be some other state-specific requirements or tribal requirements, depending on what rules are promulgated in that jurisdiction. They're usually spelled out as specific conditions. Like, is it relevant to unique receiving water or significant materials that you have present at your site? All permits are going to have a reporting requirement, like doing discharge monitoring reports. Annual reports, if you are transporting stormwater or waste materials off-site, if you're doing hydrostatic testing activities. They'll include notification requirements, if you were to have a spill, for example, who to call, when, what's the frequency. I think the trickiest part of notification requirements is usually that frequency is, when it says immediate, what does immediate mean? How quickly do you need to pick up the phone and make that call? The records that you need to maintain and the duration of how long you need to retain those records will be spelled out in your permit. And some standard conditions about prohibited discharges, like, you know, if you're not allowed to have any sanitary waste discharges or hazardous waste, there's usually some general language about that. Next slide, please. So there are two different types of effluent limits that a wastewater discharge permit could have, water quality based or technology based. Water quality based limits are going to be unique to the discharge location. What's the receiving water, and what is the water quality of that receiving water? What are the applicable water quality standards for that water body? And what will happen is that you know, the NPDES permit writer will look at those standards of the receiving water, see what your current water quality is of the effluent, evaluate the potential for the reasonable potential, excuse me, for discharge to exceed that water quality standard of the receiving water, and then calculate limits from that. And so then typically these limits tie back to a flow rate so that you have both a water quality based limit or also a loading limit. So what is your flow rate times your water quality standard and data? And if you discharge to an impaired water, then the water quality standard is not meeting its designated use, then you're probably going to have additional restrictions for specific pollutants. Technology-based effluent limits are basically the minimum end of pipe performance, and they're designated by industry sector and subsector. And right now, there are no nationally established effluent guidelines for petroleum bulk storage terminals at this time. So the agencies are using best professional judgment to impose limits. And that's usually things like oil and grease, where, as I mentioned before, you know, looking for sheen, foam, discoloration, those kinds of things. So before we move on to industrial stormwater, I'll pause and see, Al, if there are any questions from the room.
There don't appear to be any questions, but real quick, are there any questions normally? We appear to be okay.
All right, great, thank you. So we'll move now to a discussion of industrial stormwater. If you go to the next slide, please. So this is stormwater that contacts industrial activities and or significant material. So you know, essentially that is if you have both your SIC code, your standard industrial classification code, the federal regulations outline what types of industries would be subject to industrial stormwater requirements just by the nature of their activities, because they may have exposure to stormwater may come in exposure with significant materials. So based on the federal regulations, petroleum bulk stations and terminals may have to have industrial stormwater coverage for portions of the facility if you're doing things like vehicle maintenance, because there could be exposures to oil, grease, you know, painting, refueling, lubrication, those kind of things, or equipment cleaning. Crude oil pipelines and refined petroleum pipelines do not require industrial stormwater coverage. But if you're having any distribution, you know, if you've got loading racks, unloading racks, those kind of things, so there's potential for contact with stormwater at that point. So you could require industrial stormwater permit. Next slide. So industrial stormwater permits have a lot of the same things that we just discussed for a wastewater permit. One of the beefier items, though, is your stormwater pollution prevention plan that includes your best management practices. So you're identifying, you know, where do you have exposure to significant materials? What types of best management practices are you going to implement? When are you going to inspect those? What are your procedures? So that plan would be a separate living document from your permit, and your jurisdiction may or may not require you to submit that, but you would have to have it available for inspection if someone were to come to the facility from your regulator and take a look at it. And typically that stormwater pollution prevention plan is going to spell out your BMPs, how often are you doing inspections, you know, what type of monitoring do you need to do? You know, what is your maintenance schedule? How are you training your employees on these requirements? You know, what type of reporting and record keeping do you need to do? And if you've documented that you have a conditional exclusion for no exposure, it basically allows a facility with no exposure for industrial materials to rain, snow, or other precipitation that you can submit that to your regulator and say, you know, we're documenting this. We don't have exposure. Next slide, please. Construction stormwater comes into play if you have ground disturbance activities that are greater than or equal to 1 acre. And that could be also, you know, if something is happening nearby, like within 1/4 of a mile, you could be cumulatively looking at 1 acre, even though individual activities are less than that. You know, if it's all part of what's called a common plan of development. Permit coverage is typically under general permits, but there can be also individual permits as well. And you need to maintain this permit essentially until the construction activities are done, and then you reach final stabilization. And typically final stabilization is if you are putting down gravel or paving, those kind of things are done, and any areas that you're reseeding reach 70% uniform cover is most states and regulators follow that 70% guideline. Next slide. So your stormwater permit is going to spell out, you know, what are the conditions for best management practices. You know, might be silt fence, biologs, erosion control fabric, those types of things. What does your stormwater pollution prevention plan need to include? What frequency do you need to do inspections? That's oftentimes, you know, once a week or after a rainfall event. A lot of jurisdictions might use a 1/2-inch rainfall within a 24-hour period. I'm familiar with a few states that it says if there's water discharging from the site, it's a little nebulous. So making sure you understand the frequency of your site inspections, and if you do a precipitation event inspection, how to reset your clock. What's your maintenance schedule going to be? You know, as the construction is evolving, if you need to fix some silt fence or supplement, add new BMPs to manage your stormwater. How are you training your staff, your contractor on the requirements of the permit? Record keeping, you know, is typically keep all your inspection records, maintenance of BMPs, training for a period of 3 years. What does final stabilization mean? As I mentioned earlier, you know, if you are paving or graveling a whole site, well, once that's done, you're stable. But if you have any portions that are going to be seeded, then paying attention to what that stabilization criteria is. And then if you have any new impervious surface that's subject to permanent post-construction stormwater management requirements, that's going to be spelled out in your permit as well. You know, if there's, here in Minnesota, for example, you calculate the volume of a 1-inch instantaneous rainfall event on your impervious surface and figure out the volume that you need to treat. You know, and are you looking at infiltration or wet pond? Those are the types of requirements that the permit's going to typically spell out. And with that, I will end the NPDES discussion. I'll hand it over to my colleague, Greg Patton, but I'll pause here again if there's any questions on NPDES programs. Thank you.
Everybody know what an SPCC plan is? Right. So 40 CFR, which one goes?
That guy.
Okay. So regs are 40 CFR 112, implemented under or updated under Open 90. The Oil Pollution Act was implemented by 4 different agencies: EPA, Coast Guard, DOT, and Department of Interior. So everybody's got kind of slightly different plans. There's overlapping that we're going to talk about later. But for EPA, the applicability is determined by 2 parts. One is you have to have a harmful quantity spilled to a navigable water. The second part of that is you have to store with 1320 gallons. In containers greater than 55 gallons. So, you know, the regulations are governing just storage of oil. So you'd think EPA would define what an oil is, but they don't, right? So you do have kind of a clue when it says a harmful quantity discharged to a navigable water. The harmful quantity is actually defined in 40 CFR 110 as a sheen. So if you've got a sheen going to a navigable water, that's considered a harmful quantity. But that's the extent that EPA really defines what an oil is. What you do have though is Coast Guard has a list, right? I don't know if everybody's seen that. Coast Guard has a list of what they consider oils, but nobody else would consider oils. Really kind of off the wall stuff, but it does include things like, you know, animal fats and vegetable oils. But there's a lot of other things in there that get pulled in that you need to know about and check so that you don't miss stuff when you're counting towards your 1320. Also, the storage is not just drums and tanks. It's oil field operational equipment such as transformers, that kind of stuff. And then DOT jurisdiction, right? So we're talking, we're kind of focusing on terminals in this presentation. Terminals are generally going to be regulated by DOT, PHMSA, and they would be considered breakout tanks. What happens is if you get a loading rack or a LACT unit that's transferring oil into that breakout tank, then EPA says, oh, wait a minute there, that's also going to be subject to our rules. So now you've got a tank that's subject to DOT, breakout tank, 194, I think, their spill planning rules, and EPA spill planning rules. So on the surface, SPCC planning is pretty straightforward stuff, but when you start talking about the jurisdictional overlap between DOT and Coast Guard, and in some cases, Department of Interior, it can be a little bit complicated. So if you go through that process, you count your oils. Oh, something that we needed to say. I was going to say they have to be signed by a PE if you're storing over 10,000 gallons. Anything under 10,000 gallons and above 1320, a facility can self-certify, right? They don't need a PE to sign off on that plan. There's some criteria like no tank can be over 5,000 gallons, and there's some other no spill requirements. So if you do have to prepare an SPCC plan, they're kind of short, and it's spelled out in the 40 CFR 112 regs, right? So, you know, one of the biggest things that costs money is making sure your containment is up to snuff, which is 100% plus the 25-year, 24-hour storm event. Also, you need, in some states like California, you need to be really careful about permeability. A lot of the other states are kind of like gravel works just fine, where some states might say, no way, that's not going to work, like California. So The SPCC plans don't need to be submitted to EPA unless you have a spill, and then they'll ask for it. So one last thing about SPCC planning. The kind of one of the hidden requirements under SPCC planning that some people miss is the requirement to prepare a substantial harm determination, which is just appendix C2 of the regulations. And it's a question list of, do you store over 1 million gallons, and do you have the potential to impact navigable water? And that's
Very good.
the other thing I wanted to point out is navigable water. What Rachel was talking about, the definition of water of the US, the SPCC rules have flip-flopped them back on navigable water. There used to be a separate definition for navigable water. Now, if you go look at the SPCC rules, it says sea waters of the US. So that's been flip-flopping back for like 5 years. So, but now it's waters of the US. Yeah.
About the PE signature, you mentioned about the 10,000 gallon threshold of oil. Is that like, you know, kind of like pure oil content, or if I have a soft oil tank, kind of like only 10%
Yes.
or 1%?
So I probably moved off what the definition of an oil is too quickly. A good example that will answer your question is ethanol, right? Ethanol is not an oil. But if you add 2% denaturant natural gasoline into your ethanol, you know, you wouldn't necessarily say it's an oil, but if you take a sample of that and you pour it and mix it in with water, guess what? You get a sheen. Therefore, you fail that harmful quantity threshold, right, of not producing a sheen. So now that whole mixture, ethanol, is an oil. So if you've got slop water that's, you know, 75 or let's say 99% water, and you get a little bit of oil in it and you spill it, chances are it's going to create a sheen. Therefore, that whole tank is an oil tank. And the entire shell capacity of that tank, not just the amount of oil stored in there, has to be counted towards your, you know, you're well over your 1320, but towards your 1 million gallon threshold. That's an excellent question. I'm glad you asked that, because I kind of missed that. I wanted to say something about that. All right, so we've got our SPCC plan. It addressed our containment. The other thing is, if we've got transformers or transfer areas, those need general containment. Pipe runs that are outside of containment need to have general containment. And general containment is just, you know, your plan has to describe what kind of spill equipment and personnel you've got that you're going to implement to keep that oil from going off site. So general containment, there's a security planning requirement. And then generally you'll have a tank list in your SPCC plan that lists out the tank, the year it was installed, the control measures you have on it so that you're not going to overfill it. So what level controls, and then the types of secondary containment. Are there any other questions on preparing an SPCC plan? If they come up later, you can ask me.
Secondary containment, can you use anything other than just physical secondary?
Yes, you can use a double wall tank. So a double wall tank is just a tank that within a tank. And you've got an interstitial space that you can monitor to make sure you don't have spills. You can use remote impounding, so you can have like a general containment for your rails transfer areas. Well, that would be loading racks have to have size specific containment also, right? A transfer area and a loading rack, does everybody know the difference between that? That's another thing that EPA is kind of flip-flopped on. If you're just transferring oil from a bulk tanker into a tank and you're using a flexible hose, kind of running it on the ground, that's just a transfer area that needs general containment. If you have a loading rack, which is a fixed rigging, you know, so that you can get on top and top load or whatever you need to do to the tanker, and it's made to do volume of tanker trucks moving through, then that's considered a loading rack, and that needs specific size secondary containment, right? So that would be 100% plus the 25-year, 24-hour storm event. And to answer your question, that can be remote impounding. Rail cars typically have a spill pan that collects whatever spill it would be and directs it to a very large spill containment area, typically the tank farm. You can also have underground tanks serve the same function. So lots of opportunities are options for secondary containment. So, like I said, one of the things that you also need to do with your SPCC plan is do the C2 determination. And that is essentially a set of questions. And the one that usually catches most facilities is storing over 1 million gallons and the potential to impact a navigable water or navigable water or wildlife. So which would be like a marshy area with frogs or fish. So if you answer yes to any of the questions on the C2 attachment, you now have to do an FRP, which is a much bigger plan. Has a lot more requirements to it. You know, an SPCC plan is this big, where an FRP is like a 3-inch binder. SPCC plan costs $2 to $3 grand, maybe $5 grand. FRP, you're in the 15 to 20, maybe more if you're looking at a refinery. So, so they're much more substantial, and you have the same problem with the SPCC plans, in that if you've got a pipeline coming into your facility or you've got barge loading or ship loading, then you're also kind of crossing into the Coast Guard's territory, as well as potentially DOTs. So if you've got if you just have a terminal and it's just a breakout terminal and it's pipe in and pipe out and no other way of adding crude oil or whatever to your terminal, then you're just regulated by DOT. But you're looking at a refinery, there are lots of refineries that are subject to all three programs. And in that case, there's something called an integrated plan. And this one, basically, there's a lot of different templates out there that you can use. But this one essentially has all the different components of all the different agencies. And then in the back, you've got a cross-reference matrix to kind of show each agency where their specific requirements are being met. You know, makes sense because now if you got a spill, you don't have to think about, well, is this a pipeline spill or is this an EPA spill? Which spill plan do I need to get? So most facilities will come up with an integrated plan. I don't think there's anything else to say about that. When we're talking about facility response plans, the facility response plan has to be submitted to EPA. SPCC plans don't have to be submitted to EPA, but the FRP plan is required to be submitted to EPA, and it also has to be submitted to the Coast Guard if you're subject to the Coast Guard and DOT. All the agencies, because they're all these FRP planning requirements are all part of that Open 90 Act, so they all have kind of the same requirements. So when you fill out your substantial harm criteria form, you submit it to EPA, and then they determine whether it's significant and substantial. If it's significant and substantial, then they have to approve it. So they go through and they make sure that your plan is meeting everything that they want it to have in it. And then they'll send you back, if you're Region 5, they'll send you back all kinds of stuff to fix, right? If it's just, I've never seen anyone that was not significant. Everybody says they're significant if you're potential impact water. So I would just plan on it being reviewed by EPA and having to be updated to get it back. So I think that's it for SPCC FRP. There's more there's fun stuff we could talk about if you guys get out into production, right? If we're out in the oil fields, there's gathering lines, and the jurisdiction between DOT and EPA out in the production fields gets a little kind of complicated. So if you want to talk about that later, I can get my notes and we can go through it. So the SPCC rules, like I said earlier, are just covering oil. A lot of states look at that and they say that's great, but you know, what about all the other stuff you're storing in your tank? So a lot of states have above ground storage tank rules. Some of them are as simple as registration, but like Minnesota, we've got a whole big major facility permit that is the equivalent of essentially the FRP planning for non-oil storage tanks. So there's other states that have similar programs. Some of them are just notifications, making sure that when you build a new tank, it gets an approval. Iowa, they require you to get an approval so that you're doing it right, or they get their money, right? So, and then in your SPCC planning requirement, if you have a field erected tank, right, the tanks where they bring in all the parts and then they weld it together on site, those tanks need to be in some sort of an inspection program. And it's up to the facility to decide whether it's API or STI, whatever one they want to use. But whatever you decide you're going to go with, you have to document it in your plan and then implement that. So API 653 is a 5-year internal and a 10-year plus extra, opposite, 10-year internal, 5-year external. And the 10-year can be pushed out. The one slide that we didn't add to this is underground tanks. Underground tanks are regulated under 40 CFR 280. It's a federal rule, but states also have their own underground storage tank program sometimes. So occasionally you'll have sumps associated with your above ground tanks for sumping water from the tanks. You need to be careful about whether those are getting pulled into an underground tank, or if they're exempt, then they're regulated under the SPCC rules. That's it for SPCC and FRP. That's the fastest I've ever gone through that. We can talk more about it if you want. Next topic I've got is hazardous waste. You guys excited about that? That's what I thought, yeah. All right. So hazardous waste, actually it's solid waste. Anytime you discard something, if you're an industry and you're discarding something, it's a solid waste. Solid waste includes liquids and containerized gases, right? Big circle is solid waste. Anytime you discard something, you also have to make a determination whether it's hazardous or not, which is the subset. So how do you go about deciding whether your solid waste is a hazardous waste? It's a 3-step process. First step is, what's the first step? Oh, apply exclusions or exemptions, right? So am I excluded from solid waste? Am I excluded from hazardous waste? So I apply my exclusions and exemptions. If I can't find any exclusions or exemptions, then I need to go to the next step, which is it a listed waste? 4 listings, F, P, K, and U. F and Ks. F and Ks are, those are industrial waste or industrial activities, or just an industry type waste. So it's associated with like refineries have their own listed waste. There's some solvents that an industrial use solvent for solvent properties is an F listed waste, right? For solvents. And then there's the P's and the U's. The U and P's are just basically pure chemicals that are discarded or spilled. The P's are more toxic than the U's. Right, so we're going to be covering the waste, kind of these topics over here: hazardous waste, universal, industrial, the next couple of slides. For terminals, we wanted to call out contaminated soils. There's a potential for soils to be contaminated at your petroleum site. So making sure that you've got some sort of a plan to address the contaminants that might be in the soils. Don't just assume that they're non-haz or clean soils and use them as fill. I want to test them. Talk about sampling. A couple slides. Wastewater. Rachel brought up a little bit. There is an exclusion or exemption from BRCRA for wastewater, and it's 2 parts. First part excludes the equipment and the treatment system itself, and the second part excludes the wastewater once it's discharged from the end of the pipe. While the wastewater is in the pipe, it's regulated as hazardous waste still. That makes sense? The piping, the tanks, because RECRA regulates tanks and containers. But the piping and the tanks and the equipment in the wastewater system are excluded. And the wastewater itself isn't excluded until it reaches the end of the pipe and it basically is discharged per the NPDES permit. So that's the other key too. This whole system has to be under an NPDES permit. So if you were to take sludge out of your wastewater treatment system and it was from a listed waste at a refinery or a listed process, that sludge would be a listed waste. So everybody's nodding their head. Once we have a hazardous waste, we have to manage it. We manage it by determining, we're using an exclusion. The VSQG, SQG size generators are all exclusions from having to get a RECRA permit. So in order to apply those exclusions to say I'm an LQG or an SQG, you have to calculate how much waste you're producing in a month. So not how much waste you shipped off in a year, or not how much waste is on your manifest. It's how much waste did I generate in a month. Then, so you have to track it, and then you can see the threshold. If you're over 2,200, then you're an LQG. LQGs have a lot more requirements, more training, more reporting, less storage time, right? So you can accumulate for 90 days if you're an LQG. SQGs can store up to 180, 270, depending on how far you ship it. And VSQGs, whatever. VSQGs is the new term, right? It used to be conditionally exempt. That just changed, like, I don't know, I'd say last year, but it's probably longer than that now. Whenever that changed, yeah. So,
Usually less than.
which one?
Less than 24.
Yeah. My job. You're right. It should be less than 220 pounds a month. Put these slides together.
It's not a waste bag, so kind of like.
Yeah, it didn't make sense because I was saying the exact opposite. Less than 220 is your VSQG. 220 to 2,200 is SQG and then LQG. So, cool. So that's that slide. So these are some examples. D001, we talked about characteristics, right? So, or did I even get that far? I stopped. How about that? I went to, so there's three, right? So it's the excluded, then there's the F listed, and then there's characteristic. So characteristic, the four first ones are ignitability, corrosivity, and reactivity, and then toxicity, right? So flammability is less than a flash point less than 140. Corrosivity has a pH greater than 2, less than 12.5. Reactivity is like cyanide, sulfide bearing type waste. And then the rest of the D codes are considered the toxicity codes. And that's where you've got metals, VOCs, and semi-VOCs. For the semi-VOCs, the metals, the toxicity characteristics, there's a TCLP analysis that you need to run. And then with that, you compare it to certain thresholds, right? So benzene would be an example. Benzene has a TCLP limit of 0.5 milligrams per liter. So if you're over 0.5, you do a TCLP test, like your water from your hydro testing. Once you get that out, you separate it from whatever crude oil you've collected. That water, if you're going to ship it off someplace and it has a benzene concentration of greater than 0.5, it would be a RECRA hazardous waste. So back to my D001 now that I've caught up. Ignitability, the flash point is less than 140. And aerosol cans just recently got put into universal waste, and we got a slide on that. But if you were to send off aerosol cans as hazardous waste, then it would be a D001 ignitable. Another interesting thing about D001 is that it applies to liquids. So if you were to spill gasoline on the ground, clean it up, and then send a sample of that dirt to a lab and ask them to do a flash point, you'd get a flash point less than 140, but would you apply D001? Trick question. The answer would be no. Even though you've got a flash point below 140, the definition of D001 requires it to be a solid, or it says a liquid with a flash point of less than 140, right? So unless you've got free liquids, you don't apply D001. Another trick question for D002. D002 has to have a pH of 2 to 12.5, but it has to be aqueous, and it has to have at least 20% aqueous. So if you've got another solid, you have a whole thing of sodium hydroxide, the pH is 14, right? But it's a solid. So would it be a D002? No, because it has to be aqueous. And the other test for corrosivity is it has to corrode steel at a certain rate, and it wouldn't do that. So D001, D002. Solvent cleaning, this one's important for some of the labs at terminals and refineries because they're using toluene or acetone in their testing, right? And they're using it as a solvent. And we look at the F00, what, 2, 3, 3 or 5, if you're using the solvent and it's 10% of concentration before use, then the resulting waste that generated by that is hazardous waste. Another example would be if you've got brake cleaner, right? The nice stuff when you're changing your brakes, you spray down your brake and then you put floor dry underneath that. If you're using a chlorinated solvent, it's an F-listed solvent. When all that liquid drops onto your floor dry, now your floor dry carries the F code, F003, I think. And then you take that floor dry and you put it in a big 55-gallon drum of floor dry. Now you've got a 55-gallon drum of listed waste, and that's because the listed waste codes carry through. They don't go away, whereas the D0 codes, the characteristics, can go away. You're not allowed to treat them, right? You can't treat them to get rid of them, but there's ways that you can manage that. There's elementary neutralization where you can actually, get rid of your D002 code. You still have to deal with the LDR issue, but I think that's beyond this training. So yeah, being careful of the solvents that you're using and the waste that you're generating, because you don't want to take those and then dump them back into the sump that puts it back into your process or your tank, because now you've got a bigger problem. Oh, I said I'd come back to universal waste, and there it is. So universal waste is essentially EPA wanted to there's some really common things like bulbs, like spent lamps, batteries, pesticides, herbicides, and mercury switches that they just wanted to make sure that they were getting managed right. So they kind of reduced some of the requirements as long as they were managed under the universal waste program, which essentially just requires you to label it and then store it for less than a year and package it properly. And then we're adding aerosol cans to this one. Aerosol cans are also considered a unit. Same concept applies to used oil when you recycle it. So used oil that you collect, you have to send it to via a transporter that has an EPID number to an approved recycling facility. If you send your used oil off as a waste, then it's subject to the full RCRA regulation. Recyclables is another exclusion from RCRA. If you've got scrap metal, it can contain small amounts of residual material, but stuff that can't have stuff dropping off of it. And then that scrap, as long as it's sent off to be reclaimed or recycled, then it's exempt. For pipelines and terminals, off-spec fuels is another potential exclusion that we might apply. We might also apply the recovered oils. So if we're pulling oily water out of a tank or a pipe, a pig run, we can store it in a frac tank, and while we're storing it, it's recovered oil, so it's exempt, right? But as soon as we take that oil and we put it back in, now we've got the wastewater to deal with, and if it's over, benzene concentration of 0.5, then we've got a hazardous waste. So understanding the sequence of managing that is important. more examples. The bottom bullet, I think, is important. California, Minnesota, some other states have additional waste codes. So we talked about PK&U, but Minnesota has their MNO1s, MNO2s. We got additional waste codes. Other states have additional waste codes and requirements. Some of the exclusions that we apply, so talking about the recovered oil versus the recovered fuel or recyclable fuel or reclaimed fuels, each state has their own interpretation on how they allow those exemptions to be applied. So the states are allowed to be more restrictive, they just can't be less restrictive. So a lot of these exclusions you need to check with your state, because you know what you can do in Illinois, you might not be able to do in Iowa or Minnesota. And I think this is more of a list of good things to do if you're generating waste. Good to have a waste management plan, not required. Training is required, right, for LQGs, SQGs, but more is not going to be a problem. Sometimes a better training program can help. Sampling, I would say sampling equipment, but sampling in general is super important, especially if you're saying something's non-haz. If you're going to claim a pile of dirt that you just dug up that has kind of sticky odors to it is non-haz, and you're going to send it to a landfill, you better have, you know, a SW8 sampling plan, SW846 sampling plan, grid laid out and documented that soil is clean so that you can send it there, because people have had to go back and dig up landfills because they didn't do their testing, or they just took a grab sample from the center of the pile and said good enough. So sampling has to be defendable. Okay? Same thing with drums. If you got a drum that has, you know, organic material on top and water on the bottom, you don't want to just sample the top and send it off, because that's not representative of your waste stream. You need Kaliwasa to pull full column sample of that drum. The lab will be able to split it out and test it separately. Waste profiles, the disposal vendors have a waste profiling system requirement. It's not a regulatory requirement, although it does cover things like your LDR requirements and things like that, so they'll help you with that. Those expire, so you want to keep on top of that as far as making sure that you've got them updated, so that if you have a clean out or whatever, you're not scrambling at the last minute to get your profile updated with your vendor. And then along the idea of vendors, they're a good resource for information on, you know, waste code applicability and the right technologies for disposing of waste. But, you know, the specific applicability of the exemptions and exclusions to your facility, you know, they might have an opinion on it, but it's really up to you guys to make sure it's right. And then soil management plan. I think that's really important for like refineries and terminals that have a lot of history. So that if you're going to build something or you have to dig something up, you know exactly where you're going to store it, you're going to put it on plastic, how you're going to sample it, where you're going to send it. That's my last slide. I'm done. Am I covering this one too?
This segment is back to Rachel.
Okay.
She's ready to go.
All right, next slide, please. We just have a few slides to talk about, just to think big picture. If you get the call that you have an existing facility and there's a project planned where it's going to expand the footprint of your existing facility, what to think about. So first thing to ask yourself is, you know, is it a greenfield expansion or is it within your existing footprint that you have established? That will dictate a lot of the potential requirements that you have to consider. You know, of all of the operating permits that we've been talking about today, based on the project scope, do any of those require changes to your operating permits to either start construction or need to have modifications done before you can operate? Some pretty important distinctions there. Do you need to update your SPCC plan or your industrial SWIP to include the requirements of this new expanded area? Is it going to change your hazardous waste generator status that Greg just went through because you're increasing your waste generation? Is that going to start triggering more requirements than you previously had before? And then just from the actual land disturbance, you know, is there any other specific permits that you need that are unique to construction, either at the local, state, or federal level for, you know, those ground disturbing activities, or what, you know, if you're putting a new building or structure, what those might require, or if a new storage tank requires a conditional use permit based on the zoning, just confirming that. Next slide, please. If you have a greenfield expansion, you know, that can be a little bit more involved than the construction within your existing footprint. You know, what are the adjacent uses around your facility? Is it an agricultural field? Is it in a metropolitan area where there's zoning considerations? You know, are you adjacent to wetlands or water bodies that, you know, might require additional survey work and permitting mitigation? Are there protected species that could be present, or their habitat? I'm familiar with one facility that's surrounded by a state natural area. So every time a construction project comes up, these questions happen. You know, in that greenfield area, are there historical or cultural resource concerns? So usually the wetlands, protected species, cultural resources, and historic resources might require, you know, some additional surveys to identify versus just looking at desktop information or you know, saying, I've heard before, well, we own the land, so it's okay. We can do that, and it's not that simple. Next slide, please. So some of the construction specific permits and approvals that could apply, you know, we've talked already about construction stormwater. Water appropriation in some jurisdictions, you know, if you need to dewater an excavation or a trench, that requires an appropriation permit. Or we talked about hydro testing from the discharge perspective, but also where's that water coming from? You know, if you're not getting it from a municipal source, you might need an appropriation permit for that. Are you permanently filling wetlands? And if so, you may have the Army Corps of Engineers jurisdiction or a state or local program that has requirements to fulfill before you could get a permit for those activities. You know, there can be other types of local, state, or tribal permits required based on the land disturbance. You know, I've seen that, especially at the local level, can be different requirements depending on, you know, your regulatory authority at that level. Is the construction going to impact federal lands? That's probably a question to ask yourself right away because of the lag time to get those approvals and go through the environmental review process, which is the last bullet here. Some states have environmental review process, like California, Minnesota, among others, where there are certain triggers that require you to go through that state level process. And there's also federal requirements. You know, if the project requires federal approval, funding, or the feds are doing the project, are those typical triggers to go through environmental review. So all things to get ahead of very early on, as soon as someone calls you and says, we're thinking about putting a new tank here to step through the different types of things that might apply to that construction project, because you know, in some cases on an air permit, you know, may be very restrictive on what type of activities you can start construction before you have that permit in hand. And these permits can drive the construction and operating schedule depending on, you know, how complex it might be. Any questions on that topic?
We do not appear to have any questions at the moment.
All right, I pass the baton back.
Okay, I am putting on my other much smaller hat with the EPCRA Emergency Planning and Community Right to Know Act subparts. We'll talk about quickly here in terms of terminal overlap and potential regulations. So there's a couple primary sections under the EPCRA Act of 1986 that are critical to the terminal world and generally regulated industry. And they're kind of broken up into these key parts. Sections 301 to 303 is emergency planning. So that's all the pre-stuff. Then you've got the 304 section that covers emergency release notifications and what you have to do and who you have to respond and reply to or notify. Section 311, 312 talks about the reporting and storage of hazardous chemicals on site, otherwise known as the Tier 2 report. And then Section 313 is the TRI toxic release inventory. That's sort of the flip side to the storage report that talks about or inventories all of the toxic chemical releases you have from your given facility to air, water, or waste. And again, these are from a federal perspective. Some states may have differing requirements that require shorter turnaround times for notifications for some of these different programs, depending on how they're set up to manage them. So section 301 to 303 is the, as I said here, the planning portion, which if you have an extremely hazardous substance on site within 60 days, you have to submit a notification to your local agencies if it's above a certain threshold. They go to the state and local emergency response planning commissions, and you have to update these notifications within 30 days if there's a change in facility representation or 60 days if there's another relevant change to the emergency planning process. So typically, if you have a facility, you submit your notifications, your SDSs, all the hazardous chemicals you'll have on site, and then you just have to keep it current and submit changes if new things show up. But if you've also got a facility that's constantly receiving new chemicals or using new products, then this can be a little bit more of a challenge that requires more kind of hands-on maintenance as well. So then we get to release reporting. So here we have kind of a couple things to keep in mind. There's both the EPCRA, which is the employee right to, or emergency planning and community right to know act, as well as CERCLA, which is additional response threshold reporting requirements for impacted communities or areas that may experience a hazardous chemical release. There are different reportable quantities that may require immediate notification. If a RQ reportable quantity is triggered, you have to submit notifications and follow up and go through kind of what happened with those releases. The EPA has a big long list of lists, as it's known, that covers the reportable quantities for these chemicals. Then we get into the Tier 2 or sometimes Tier 1 world for the hazardous chemical storage reporting requirements. This is typically, or this is an annual report due on March 1st that covers the storage, location, and type of hazardous materials on site in any given storage container and what their storage conditions are. So in the event of emergencies, your local response agencies have necessary and helpful information to help support combating an incident. The Tier 1 is an initial report due within 3 months from when a chemical comes on site. And then the Tier 2 is the annual refreshed report that you continue to submit as your facility is in operation. Similar to some of the waste notes Greg made, certain things on the Tier 1 and Tier 2 reports that need to get counted for against the reporting thresholds are sulfuric acid and lead acid batteries, transformer oil sitting in transformers throughout the facility, fuel in addition to the large storage tanks. So if you've got small vehicle fueling facilities, transmix, oily water waste, sand, gravel, salt, if they have hazardous chemicals or components, and chemicals used by contractors, anything that's significant and substantial that's on site needs to get assessed from the Tier 2, Tier 1, Tier 2 perspective. Toxic release inventory. This is probably the most complex of all the EPCRA programs in terms of the upfront analysis and then ultimate reporting that has to happen. There are the other EPCRA rules generally apply with, I believe, few exemptions. However, the toxic release inventory is has a few targeted requirements in terms of, if you don't have above a certain number of employees, or depending on your NAICS code, NAICS code, that can dictate, along with a few other exemptions, whether you have to officially do a TRI report or not. And then what that ends up doing is you're looking at how much of a hazardous chemical did you manufacture, process, or otherwise use at a facility, and then what of those manufactured, processed, or otherwise used chemicals did you release to the air, to water, to waste, and the off-site facility impacts of those. So there's reporting triggers and thresholds to review against. It's a multimedia exercise. I think sometimes it's characterized as an emission inventory on steroids in terms of the amount of accounting that you have to do to complete the exercise. So that is EPCRA in a whirlwind, just to make sure we get to kind of all the other fun topics here. We have some other miscellaneous environmental topics, other environmental programs here. I think this might be me, so I'll just kind of keep rolling. Just some things, right? We've got monitoring wells. If you've got potential contaminated soil or water issues, there are just other, we haven't even touched on all of these in too much detail, but certainly a number of other programs and monitoring requirements that may exist. There's also Part 80 clean fuels rules that may be impactful depending on your status as well. So just a few things to keep in mind. This would not be an appropriate presentation if we didn't touch on PFAS very quickly here. I think everybody has a strong awareness of per and polyfluoroalkylated substances. From the terminal's perspective, right, we have mostly an impact from aqueous film forming foam, AFFF. It's excellent for fighting fires. It's excellent at being a legacy contaminant. So that's kind of the big one from terminals. Even with some, the legacy foams contain the really nasty stuff. Modern foams may contain shorter chain PFAS chemicals, but still, as the process is ever evolving, it likely is still going to be a potential issue as a pollutant of concern. And so what does that mean for a terminal from a PFAS angle? How are you, storing and managing your foam? Is there any leakage issues that could be a problem? How are you, keeping track of the potential PFAS-related compounds on site? What about firefighting? If you continue to identify that using AFFF with PFAS is a necessary need for safety and firefighting purposes, can you identify and mitigate risks to drinking water, wetlands, other areas? Do you have a plan to capture, collect, treat AFFF once it's been used in a fire situation? And probably the easiest one though is, and this is definitely more refinery focused, but still generally depending on your terminal size, can you use non-AFFF for firefighting practice for your training drills, or can you do training off-site and let the other facility deal with your foam management? And they can have that headache. So again, right, we've talked about a number of plans. We're just kind of hitting home the importance of incorporating that firefighting water management into the existing environmental programs and procedures to make sure that it's not an afterthought and you can be proactive rather than reactive. Let's see here. And I think the big one here, right, is pre-plan your treatment approach, especially if you're going to end up with PFAS in your on-site fire ponds, and what you're going to do with those, or what you're going to do with that, and to have a plan in place versus having to potentially build a new treatment plant to manage your PFAS impacts if you have a significant fire and event at your facility. And then also, I think another common note is PFAS can be in really, really small concentrations or really low concentrations. So having adequate and skilled sampling to make sure you get a true and accurate measurement is important as well. Finally, we have a presentation later today on PFAS and how to, did that happen already, Corey? We had another presentation this morning on some concepts and elements around sampling, because again, we don't want to be ignorant, but we also know that we may need to sample things, but also how to manage data in a world where there can be some pretty significant consequences around what to do there. So I think we can probably get that slide or get those slides to people if they want it, or it should be available through 4C. Yep, deliberate on sampling procedures, analysis, parts per trillion is a tiny number. You know, must start now for your emergency planning purposes. Closing remarks. Another big popular topic, right, has been ESG issues, environmental social governance issues. From a terminal's perspective, a big one we have is greenhouse gas emissions accounting. I said earlier that from a federal regulatory perspective, we typically aren't too concerned at terminals. However, that doesn't preclude us from the management, board of directors, shareholder, additional drivers to account for emissions across your industry or across your company, whether it be scope 1 emissions, things directly coming from the terminal, or scope 2, the indirect emissions such as energy use by your pumps and other infrastructure. And that can also include, you know, water usage, waste management, as well as part of that GHG accounting or emissions or resource use. As an environmental consultant, I am not a social or governance consultant myself, but we don't want to forget the S and the G of ESG, because that can have some pretty significant consequences as well regarding workforce diversification, the neighborhoods and communities that facilities operate in, and understanding where those impacts, you know, may fall and how they may ultimately impact reporting, data metrics and company performance. I think this is the final section as we roll into the home stretch here with a few minutes left. We've talked about all the environmental systems, programs, and topics. I mean, you can tell me what I've missed. So this will be a fun dry run. We'll tie it all together. Well, I think this was technically Corey's from last time, so I'm assuming that I know what I'm talking about here. So, right. So it's great to have all of our air programs understood, all of our water permits understood, but you know, we have baseline compliance compared to environmental management systems. There's you know, plans and procedures you can write yourself. You can have complex software solutions that manage your notifications, your tasks as a off-the-shelf, but still pretty significant effort to develop type of an EMS, or you can do more of a grassroots, work with your teams, develop programs, procedures, and have a more organic, less encompass, enable on super you know, proprietary software solution. But in terms of having some method to managing your environmental compliance beyond just the individual parts and pieces is necessary in today's complex regulated world. That's really all we had on EMS. So I think I got it, Greg. Anything again, closing notes. We talked about tank emissions. Yes. More than half a slide. We talked a lot about tank calculations. At Barr, we have developed what we call the Barr Tank Emission Calculation Spreadsheet, or BTEX, that does all the AP42 calculation routines or methodology for routine and non-routine emissions. There should be something on the flash drives. If not, you can go to you can reach out to tanks@barr.com or go to our website, or let me know and I can get you some information. That's a freely available tool we've developed that folks can use for tank emission calculations, or typically we use when folks look for us to help with tank calculations. Let's see here. Oh, we might have had some out-of-place slides. Tying it all together, compliance management. You know, again, read your permits, know your plans, make sure you've got people keeping an eye on things, whether it be training or your environmental staff. Again, compliance action plans, multimedia resources, a compliance action plan can tie together everything in one spot, be a great reference manual for training, and not just rely on, oh, there's a question, let me open up my permit. CAPs can include a whole bunch of items here in terms of roles, responsibilities, lists of requirements and responsibilities for who does what, record keeping, notifications, where to find your files and information. Just answer all your questions in one spot, typically be the one-stop shop for environmental compliance, which is, I think, really helpful, especially for when there's job position turnover. Having a good instruction manual beyond just job lists or tasks can be really important. Yeah, looks like our slides got a little bit shuffled here. So there's a little bit more on EMS, right? But ultimately, right, we're talking about creating a vision, defining programs and accountability, organizing the chaos, a little chaos in the slides here, improve transitions, implement processes for continuous improvement. It's written down, it's pretty common sense and nothing rocket science, but I think everybody can agree that there's a swirling vortex of chaos in everyday environmental work. So to sit down and really focus on developing a program, if you haven't already, can go a long way to getting across the finish line for making life a lot easier. Here's just a few, again, some environmental management system, building blocks. If we kind of a bit more of a top-down approach, why we're doing it. There's policy, either corporate or otherwise, regulatory accountability. What do we have to do? Is it spreadsheets to track stuff? Is it a document, manual, library, other key documents? We want to know who's involved, when are they involved, where do they have to do stuff, how are they going to do it, what's the evidence, what's the receipt of completion, how do we track that we're performing against our environmental management system and doing the things we're saying we're doing or required to do. And then there's the continuous improvement portion. So again, that'll be in our slide deck. And hey, that is it. Thank you everybody for sticking through the long haul here. Before you go, we have flash drives that have the presentation material on them should you want to take one home with you. And if you can, jot down some thoughts on the review form if you feel so motivated. And feel free to let me know if you have any questions or any of our other Barr folks here as well. Thank you very much. Thanks, Rachel. We're signing off here.
Thank you. Bye.